So when you search Google Earth Engine, the first website you have to get in.
Just to step by step, little bit slow. Yes. All the participants should do.
Yes, sure. So this is the web page for Google Earth Engine. If you have opened it, please let me know. Shall I move on to the next step? So here you can see a lot of options in the menu. So just to be clear, I'll tell what Google Earth Engine is. This is a platform where we can access many data sets, satellite as well as remote sensing data, and we can analyze the data in this platform itself without downloading it or without using any other tools. So here you can see there are a lot of options in the menu bar. We are going to the data sets. So if you could click on data sets. So we'll go into this web page. And if you scroll down, data sets. So if you scroll down, you can explore the different parameters and data this site is providing. So you can see surface temperature, climate, atmosphere, weather. So these are providing different satellite data for all these parameters. So here if you just click on any of the data, anyone, that is okay. This is just for creating an account we are doing this, so we'll explore the data later. So here Sentinel collection. Once you have selected a data, you will go into this website where they give the description of the data sets. If you have reached there, we can move on to the next. Once more, okay. Can you? Just select any of the data.
So different parameters are there, like to see the climate variables and weather variables. First, this section, it's a collection section. First, then for imagery, for visible range images. So these sections, and then geophysical like land cover and all these things. These sections are divided. So it's your wish, like whatever the data you want to check in that Google Earth Engine. It's your choice. You can choose any data. So in that section, anything you can use. Like I'm here choosing that Sentinel. In that section, under the Sentinel section, so many satellites are there, like Sentinel-1 and series of satellites which provided the data. So now I am going to choose which satellite data I need. So now I chose the Sentinel-1 data. So this is the
yes. So if everybody has reached this site, okay, we can move on. So if you scroll down to the end, until the end, yes, you can see that they're providing the code to analyze this data. This is like a simple code they themselves are providing. Even more, scroll down. At the end, you can see open in code editor. You can click on that. Click on that. Yes. So if you have clicked on that,
so now everyone reached
Any confusion, we can show it once more, where to get that. Yes. You can give your Google account here. Any of the Gmail account, you want to use it for the Earth Engine. Any confusion till here? Okay. So once you have given the email ID and password, they might ask for two-step verification if that is turned on. If not, they will ask you to enable that two-step verification in the Google account.
You will receive that code in your Gmail account.
Yes.
It's not for everyone. Some people may already turned on that two-step verification.
So when you are giving the mail, if you haven't enabled the two-step verification, some people might get to enable it, that option to enable the two-step verification. So I would suggest to do that, and then you might be able to sign in.
So when you are accessing the Google, I think you have to do access to the Google Drive. You use this Google, I think it provides some images, some data also. You can download the data. It will be stored in your Google Drive. That's why you have to do the access. Go down. Hello. Okay. I think most of the people are
Yeah, okay. So this is, yeah, here where we are going to register. So I want to register a new project. Yeah. This one. This is that.
So we already.
you have to give the information here. You have to agree the terms and conditions.
So I am doing extra thing.
Then you continue your
Actually, he already has an account. That's why the verification came first. But I think now you are having to down. Yeah, I think. Okay. I want to register in a new project. Yeah? Okay.
organization, right? Organization, right?
Yes. So academic. Yes. So academic. Yes. 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 or academic institute, the first option.
Yes, you have to try.
Correct.
I don't have much time, man. You can keep your name, whatever you want. Great project.
Create project.
Here parents are also.
No, no, that is not needed. Create. Non-commercial use.
It is a commercial use, you have to pay. As academic use, this is free of cost. Organization
Yes.
Organization,
Go down.
no organization.
I hope everybody is seeing these two options, commercial versus non-commercial use. We'll be going to non-commercial. And you can click get started. So here you will have to give your details to register.
This is a government or public private. Needs to design a bit. Pages.
Yes. Select a project and you can add a project, new project. And you want non-profit.
Giving project name, not maybe.
You will get two options, commercial use, non-commercial.
New project.
Yes. Create.
This is no organization.
That is okay.
Then I click create.
Public or private academic. And first one select.
Yes.
Yes.
Yes. Okay. I'll come. India. It's not.
Check non-commercial is your organization considered one of the following?
You can just this one. India is not okay. Can I check? This one only, right? Oh, here this public or private. Oh, maybe now you can select this. The option changes with it. This like any institute you want to give. Name of institute.
Understanding లేదు చేశారు చేయలేదు కదా. choose your plan. Needed undergraduate students low. Okay, కమ్యూనిటీ పెట్టండి లేదా ఏది పెట్టినా
కమ్యూనిటీ పెట్టండి. డిస్క్రైబ్ యువర్ వర్క్. ఏది తీసుకున్నా పర్లేదు, మిటిగేషన్ తీసుకోండి. అగ్రికల్చర్, ఇవన్నీ ఇంపార్టెంట్ కాదు ఇప్పుడు ప్రజెంట్. Choose your community. And next mitigation, and then go for agriculture, whatever it may be, but you scroll down completely, then only you will get a OK button. If you scroll completely here down, you will get the OK button. And then click on next. Mitigation, ఏదైనా రిజిస్టర్ అండ్ దెన్ ఎనేబుల్ అని చేయండి. సో మీరు ఇప్పుడు రెడీ అవుతారు. వన్స్ ఎనేబుల్ చేసేస్తే యు ఆర్ రెడీ టు యూజ్ ద గూగుల్ ఎర్త్ ఇంజన్. సరే, నేను నిన్న మీకు ఒక పీపీటీ పంపించాను. ఇప్పుడే ఎవరు నాకు నిన్న మెసేజ్ ఇచ్చింది? ఆర్గనైజర్ కాదు, మీ వాళ్ళు ఒక రకం ఇచ్చారు. చంద్రమౌళి గారు. మీకు వాట్సాప్ మెసేజ్ పంపించాను, చూడండి, గ్రూప్లో షేర్ చేయండి. ఆయన చూడలేదండి. I'll tell it. Ganesh, I'm going to use my account. Huh? Yeah.
I used my second account.
Yeah. That's why it's important, na? Yesterday you got complete thing.
Okay. Because we have to show, you have to create a complete new.
Yes. Good job.
Okay.
Okay, you may have to help them
Okay.
when we showing this one.
Almost everyone gave register.
Yeah, you please check everyone is ready or not. Okay, మీరంతా రిజిస్ట్రేషన్ అయిపోతే దెన్ వీ గో ఫర్ నెక్స్ట్ వన్. మీ ఇంట్రెస్ట్ ఏంటి? టాపిక్ ఆఫ్ ఇంట్రెస్ట్. రిమోట్ సెన్సింగ్ తెలుసా? వాట్ ఈస్ రిమోట్ సెన్సింగ్? శాటిలైట్స్. ఓకే, ఐఎమ్ గోయింగ్ టు షో యూ వైజాగ్ లొకేషన్ and then you can see how Vizag looks from a satellite point of view. Remote sensing ante, in a simple words, you are sensing an object without any physical contact. You are acquiring the information about the object. Satellites are revolving around the globe and they are capturing the information from the ground. Like it may be a building, it may be some kind of a aerosol particle, which is a dust particles, or it may be a ozone gases, anything, or temperature at any given location, or maybe a traffic or agriculture field, whatever it may be. Each of the object on the globe will emit some kind of a reflectance. That reflectance will be captured by the satellite, and then they combine everything into a map, images. Those images we are going to see now. Okay, there are three channels we basically use for the remote sensing. One is a visible channel, which just based on the reflectance. Other one is thermal channel, which is based on the emission from the object. The third one will be the microwave channel. All these channels are dependent on the frequency at which we are measuring, which are collecting the information. Okay. Now I am going to show some of the images which will be few from the land observations and few from the ocean observations. Okay. I already shared one PPT with you guys, and then you can go through that one. Without delay I am going to start this course. Now you go to the earthengine.google.com. Yeah, you open another one, you already have that account now. Now you go to the earthengine.google.com. And click on data sets. Click on data sets. Click on data sets, then it will lead to another account, another browser. So here you can search whatever you want, what kind of data you wanted. There is a US satellite. Unfortunately, Indian satellites are not available on through data Earth Engine. Okay, only foreign satellites, only limited. Not they are expanding now. Earlier it was very limited. Now it is grown like anything. So one of the satellite very useful for our land cover. How the buildings are, how the city is expanding. To get all this information, there is a satellite we used for like. Last 60, 70, last 50, 60 years is called Landsat satellite. It is a NASA satellite which provides you the information about the land. So we can click there, Landsat, Landsat 8 or 9 also okay, not a problem. Landsat 9. I think it's better we go with the Landsat 8. They don't have the much data in the Landsat 9. Okay. So here you can click any one of this one, surface reflectance. If you click that one, you will get the information about the data availability. From which date to which date the data is available. The Landsat 8 data is available from 2013 to till now, it is continuing. Okay. Data producer USGS, it is European, US government, and then you go, there will be a description about the instrument, the satellite. You can go through that one, it gives complete information, and then there is another option called bands. Under which band it collects the information. It has a multiple bands. So if you see, there is a concept called a wavelength. this wavelength, under this wavelength only it is collecting. The satellite will have some sensor, it collects the information with this wavelength, within this wavelength. So that will be recorded and then they combined with multiple things. Then we will get the final output. Okay, for example, if we want to study about the coastal aerosols in the coastal region, we can go with the B1. If you want to study about the surface reflectance, we go with channel B2, like that. And then aerosol attributes will be here. And there is another bands are here. So now my idea is download. Okay, some of this data will be given here. If you go down, the code is generated here, Java code. We don't need to learn any Java code here. You just copy and paste in your Google Earth engine, then it will be opens, downloads all the data. So what I have done here it provides you the information from where you are collecting the data. Data set is image collection from Landsat data. Yeah. Which satellite? Which they are working? This one?
No, that choosing chat, which lateral.
Okay. Okay, fine.
Everyone reads this page.
సో చెప్పండి ఏదైనా డౌట్ ఉంటే ఇక్కడ ఆగారా తెలుగులో చెప్పనా సరే ఇక్కడికి వెళ్ళారు సర్ఫేస్ రిఫ్లెక్టెన్స్ చూజ్ చేసుకోండి చూజ్ చేసుకున్న తర్వాత మీకు డీటెయిల్స్ వస్తాయి శాటిలైట్ డిస్క్రిప్షన్ వస్తుంది అండ్ దాంట్లో వాడే బ్యాండ్స్ ఇన్ఫర్మేషన్ వస్తుంది మనకి ఇక్కడ ఏంటంటే ప్రజెంట్ ఒక డేటాని డౌన్లోడ్ చేయాలి దానికోసం ఏంటంటే ఇక్కడ కోడ్ ఉంది జావా కోడ్ కోలాబ్ పైథాన్ కోడ్ కూడా ఉంటుంది బట్ ఐ థింక్ ఇట్స్ జావా కోడ్ ఈజ్ బెటర్ కాపీ చేసుకోండి దీన్ని లేదంటే ఇక్కడ ఓపెన్ ఇన్ కోడ్ ఎడిటర్ క్లిక్ ఆన్ ఓపెన్ ఇన్ కోడ్ ఎడిటర్ ఓకే this is a problem man. Okay, I'll do it, don't worry. క్లిక్ చేసి ఆల్రెడీ మీరు ఒక ప్రాజెక్ట్ క్రియేట్ చేస్తున్నారు ఆ ప్రాజెక్ట్ నెంబర్ని సెలెక్ట్ చేసుకొని సెలెక్ట్ కొట్టండి నెక్స్ట్ రిజిస్టర్ ఆల్రెడీ రిజిస్ట్రేషన్ అయిపోయింది ఆథరైజ్డ్ ఆల్రెడీ మీరు క్రియేట్ చేస్తున్నారు కదా స్టార్టింగ్లో ఓకే ఇక్కడికి వెళ్ళి ఓపెన్ ఇన్ కోడ్ ఎడిటర్ క్లిక్ చేయండి క్లిక్ చేసిన తర్వాత మీకు ఇలా విండో ఓపెన్ అవుతుంది మీకు అక్కడ ఏదైనా మీ ప్రాజెక్ట్ యాడ్ చేయాలంటే ఆల్రెడీ ఎగ్జిస్టింగ్ ప్రాజెక్ట్ సెలెక్ట్ చేసుకోండి అయిపోతుంది ఆ అబ్బాయికి తెలుగు రాదండి వాళ్ళ స్టూడెంట్స్కి ఎవరికి తెలుగు రాదు అక్కడ కొత్త పేరు ఇచ్చుకోవచ్చు లేదంటే మీరు పాత పేరునే చూజ్ చేసుకోండి ఇప్పుడు ప్రజెంట్ పాత పేరు చూజ్ చేసుకోండి ఓకే మీకు ఈ స్క్రిప్ట్ మీరు ఎక్కడి నుంచి వచ్చారు అది ఓపెన్ చేయండి ఇది కోడ్ రాలేదండి వచ్చింది చూడు వచ్చిందా వచ్చింది మీకు రాలేదా కోడ్? ఒక అది తర్వాత చూద్దరు, ముందు ఇక్కడికి వెళ్ళండి. ఎర్తింగ్ డేటా తీసుకోలేదు, ఇక్కడ ఓపెన్ ఇన్ కోడ్. మీకు రాలేదు? ఇందాక ఇక్కడ దగ్గర ముందుకు రండి, ముందు దీనికి ఇక్కడ క్లిక్ చేయండి. I am authorized for existing. సెలెక్ట్ చేసుకోండి. సెలెక్ట్. మీకు రావట్లేదా? అక్కర్లేదు. మీరు ఏది పాతది అది కిందకి రండి, అది చూపించండి ఒకసారి నాకు. ఇది ఇక్కడ క్లిక్ చేయండి, ఇది క్లిక్ చేయండి దీని మీద, ఇది క్లిక్ చేయండి. ఇది ఓకే. ఆథరైజ్డ్ ప్రాజెక్ట్ సెలెక్ట్, కంటిన్యూ. ఓకే. Okay, I think everyone got this window. Okay, now first we will run this code and then later I will show you with I send 3 codes with you in WhatsApp. We will try with those 3 codes. Okay, so I am going to run here. Go to run button here. There is a run button on that. Run script. You click on that. Just click on that. ఎర్రర్ వస్తుందా? ప్రోగ్రామ్ రాలేదా? కనపడలేదా? ఒకసారి ముందు విండోలోకి వెళ్ళండి. ఈ విండో, ఆ విండో కాకుండా ముందు ఇంకొక విండో ఉంది కదా, UGCSG అని. దాని మీదకి వెళ్ళి అక్కడ ఓపెన్ ఇన్ కోడర్, ఇది కాదు, మీకు వచ్చేసింది. దీని మీద క్లిక్ చేయండి. ఇప్పుడు వచ్చింది చూడండి. ఈ కోడ్ వేరండి, అసలు కోడ్లు మళ్ళీ చూద్దాం. అసలు రన్ చేయటం ఎలా అనేది చెప్పడం కోసం రన్ మీద క్లిక్ చేయండి. మీరు కొద్దిగా అది జూమ్ అవుట్ చేసుకుంటే మీకు మొత్తం గ్లోబ్ మొత్తానికి వస్తుంది ఆ డేటా. ఇక్కడ ఏంటంటే నేను రిస్ట్రిక్షన్ ఏం పెట్టలేదు, ఎక్కడ సెలెక్టివ్ రీజియన్లో తీసుకోమని. ఇది మొత్తం గ్లోబ్ మొత్తానికి వస్తుంది. సో కొద్దిగా టైం పడుతుంది, బట్ ఐఎమ్ గోయింగ్ టు టేక్ యూ నెక్స్ట్ వన్. ఓకే, ఇది అయిపోయింది కదండి. దెన్ మీకు ఇచ్చిన దాంట్లో 3 ఆప్షన్స్ ఇచ్చినాను, 3 శాటిలైట్స్ తీసుకున్నాను. ఒకసారి అది ఓపెన్ చేయండి పీపీటీ. ఇది ఫస్ట్ ల్యాండ్సాట్ డేటా, ఇది ల్యాండ్సాట్ 8 డేటా. దీంట్లో నుంచి నేను ఒక కోడ్ తీసుకున్నాను, ఆ కోడ్లో లొకేషన్ ఇచ్చాను అనమాట, ఇండియన్ రీజన్ లొకేషన్ ఇచ్చాను. ఇవి దాంట్లో ఉండే బ్యాండ్స్, కోస్టల్ బ్యాండ్స్, బ్లూ బ్యాండ్స్ ఇవి వస్తాయి. అవి తీసుకొని నేను ఓవర్ వైజాగ్ ఎలా ఉంటుందో చూపిస్తున్నాను మీకు. మీరు ఏం చేస్తారంటే జస్ట్ ఈ ప్రోగ్రామ్ని కాపీ చేసుకోండి. పాత్ ప్రోగ్రామ్ని రీప్లేస్ చేసేయండి. ఇందాకున్న ప్రోగ్రామ్ మీద రీప్లేస్ చేయండి దీన్ని. ఓవర్ వైజాగ్ మీకు చూపిస్తాను, మీ ఊర్లో కూడా ఎలా చేసుకోవచ్చో చూపిస్తాను. వస్తుంది, కోఆర్డినేట్స్ తీసుకొని చూపిస్తాను. ఓకేనా? పీపీటీలో మీకు 6th స్లైడ్లో ఉంది చూడండి. ఈ కోడ్ ఇంకో చోట నుంచి కూడా తీసుకోవచ్చు, అది ఎలా కూడా చెప్తాను మీకు. మీరు ఇప్పుడు ఈ కోడ్ కానీ చూస్తే ఇక్కడ జామెట్రీ పాయింట్ ఇచ్చున్నాను నేను, ఓవర్ వైజాగ్ ఏరియా. తర్వాత ఇమేజ్ కలెక్షన్ వచ్చేసి ల్యాండ్సాట్ 8 శాటిలైట్ నుంచి. అండ్ దెన్ ఇక్కడ నేను కొన్ని ఫిల్టర్స్ తీసుకున్నాను. ఫిల్టర్స్ ఏంటంటే ఫస్ట్ వన్ డేట్, ఎక్కడి నుంచి ఏ డేట్ నుంచి ఏ డేట్ వరకు. మనకి 1 డేలో శాటిలైట్ రావాలని లేదు, అందుకని చెప్పేసి ఐ యావరేజ్ ఇట్ ఫర్ 1 ఇయర్. 1 ఇయర్ డేటా తీసుకున్నాను. శాటిలైట్ మెయిన్గా చూసేటప్పుడు ఏంటంటే ప్రాబ్లం పైనుంచి చూస్తుంది కాబట్టి మీకు క్లౌడ్ వచ్చింది అనుకోండి, క్లౌడ్ వల్ల ప్రాబ్లం వస్తుంది. దానికని నేను ఇక్కడ క్లౌడ్ ఫిల్టర్ పెట్టుకున్నా. క్లౌడ్ కవర్ 10% ఉంటే మాత్రమే తీసుకోమన్నా. 10% కన్నా ఎక్కువ ఉందనుకోండి మొత్తం క్లౌడ్ కనిపిస్తుంది. అది చూపిస్తాను, అది కూడా అదే మారుతుంది అనేది. సో ఇలా పెట్టేసి తర్వాత ప్రింట్ అవైలబుల్ బ్యాండ్స్, ఏ బ్యాండ్స్ అవైలబిలిటీ ఉన్నాయో మొత్తం అక్కడ ప్రింట్ చేయమని చెప్పాను. తర్వాత అవన్నీ ఒక అపెండ్ చేస్తుంది, ఒకదానికొకటి డిఫరెంట్ లేయర్స్ని అపెండ్ చేస్తుంది. B1, B2, B4, B3 అవన్నీ అపెండ్ చేసి మనకు ఒక విజిబుల్ స్పెక్ట్రాన్ని ఇస్తుంది. ఇప్పుడు ఒకవేళ ఓన్లీ రెడ్ కలర్ తీసుకున్నామంటే మనకి ఇమేజ్ కరెక్ట్గా ఉండదు. సో అందుకని నేను RGB కలర్స్ 3 తీసుకొని కంబైన్ చేసి ఈ ఫైనల్ అవుట్పుట్ తీసుకురాబోతున్నాను. ఇది అయిపోతే మీరు ఒకసారి రన్ మీద క్లిక్ చేయండి. మీరు రన్ మీద క్లిక్ చేస్తే మీకు ఒక ఇమేజ్ వస్తుంది, శాటిలైట్ ఇమేజ్. దాన్ని జూమ్ ఇన్ చేసుకున్నారనుకోండి, మీకు అంతా ఎక్కువ క్లౌడ్స్ ఉన్నాయి. ఇక్కడ ఏమవుతుందంటే 1 ఇయర్ డేటా తీసుకున్నాను. 1 ఇయర్ డేటాలో మనకి మాన్సూన్ కూడా వచ్చేస్తుంది. మాన్సూన్ టైంలో క్లౌడ్స్ ఎక్కువ ఉంటాయి. అవన్నీ మెర్జ్ అవ్వటం వల్ల మీకు క్లారిటీ ఉండదు. సో ఇప్పుడు మనం ఏం చేద్దామంటే టైం పీరియడ్ని తగ్గిద్దాం. ఫస్ట్ నుంచి మేబీ ఏప్రిల్ వరకు పెట్టుకుందాం. సో డేట్ చేంజ్ చేసుకోండి. అక్కడ డేట్ చేంజ్ చేసుకోండి. చేంజ్ చేసుకొని రన్ క్లిక్ చేయండి. స్టిల్ సేమ్ కవర్ వస్తుంది. ఇప్పుడు ఏం చేద్దామంటే క్లౌడ్ కవర్ దగ్గరికి వెళ్ళి 5% పెట్టుకుందాం. సో నేను క్లౌడ్ కవర్ని 5% పెట్టుకున్నాను. ఇంతకుముందు ఉన్న క్లౌడ్ ప్యాచెస్ మొత్తం డిజపేర్ అయిపోయి మనకి ఆ డేటా వచ్చింది. ఇప్పుడు దీన్ని జూమ్ చేసుకున్నారనుకోండి, సో ఈ శాటిలైట్ తీసుకొని గూగుల్ మ్యాప్స్ వచ్చింది. మ్యాప్ వ్యూ కూడా ఉంటుంది. బట్ గూగుల్ దాంట్లో ఏమవుతుందంటే మీకు 2015, 6 ఆ టైం డేటానే ఉంటుంది. లేటెస్ట్ డేటా అప్డేట్ అవ్వదు, అది టైం పడుతుంది కొద్దిగా. మనకి ఇప్పుడు లేటెస్ట్కి ఇప్పుడు ఏం కావాలనుకుంటే ఇక్కడ తీసుకోవచ్చు. సపోజ్ ఇక్కడ బ్యాక్గ్రౌండ్లో ఏముందో తెలియాలంటే మీరు ఇక్కడ లేయర్స్లోకి వెళ్ళండి. గో టు ద లేయర్స్, అక్కడ క్లిక్ చేసి ఇక్కడ ల్యాండ్సాట్ 8 RGB అని ఉంది కదా, దాని మీద క్లిక్ చేయండి. కింద మ్యాప్ కనపడుతుంది మీకు. ఇప్పుడు మళ్ళీ దాని మీద లేయర్ పెడితే ఇది పెద్ద మడక దగ్గర ఒక రిజర్వాయర్ ఉంది. ఆ రిజర్వాయర్ మీకు కనబడుతుంది చూడండి. రిజర్వాయర్ యొక్క కలర్ కాంబినేషన్ మారిపోతుంది అనమాట. కింద వాటర్ యొక్క రిఫ్లెక్టెన్స్ వేరేగా ఉంటుంది. ఇంకా కొంచెం జూమ్ చేసుకున్నారనుకోండి, మీకు కోస్టల్ ఏరియా ఇక్కడికి వెళ్ళండి. ఇది హార్బర్ ఏరియాకి వెళ్తే దిబ్బపాలెం దగ్గర చూడండి, మీకు అక్కడ కన్స్ట్రక్షన్ బిల్డింగ్స్ ఇవన్నీ క్లియర్గా కనబడతాయి. ఇది ల్యాండ్సాట్ 8, దీని యొక్క రిజల్యూషన్ వచ్చి 30 meters. నేను ఇంకో శాటిలైట్ చూపిస్తాను, అది 10 meters, 20 meters ఉంటుంది. దానికి తేడా మీకు ఒక క్లారిటీ వస్తుంది అనమాట. ఓకే, ఇది క్లియర్గా ఉంది కదా మీకు. ఎక్కడ కలర్స్ రావట్లేదు? వైశాలి, కెన్ యూ చెక్? సపోజ్ ఇప్పుడు నేను మీకు వచ్చిందండి, ఏమైంది? ఇది కాదు, మీరు ఇక్కడ ఉన్నారు. 6 అది కాపీ చేసుకోలేదు. పేస్ట్ రన్ చేయండి, క్లిక్ రన్ చేయండి. వస్తుంది చూడండి. ఎక్కడ మీకు కోడ్ చేసుకుంటే ఆ కోడ్లోకి వెళ్ళండి, కొద్దిగా పైకి వెళ్ళండి. అక్కడ క్లౌడ్ ఫ్రాక్షన్ 10 అని ఉంది, అక్కడ 5 పెట్టండి. అది కాదండి, మీరు ఆ స్లైడ్ డౌన్లోడ్ చేసుకోండి. ఫైవ్ పెట్టి మళ్ళీ రన్ చేయండి. అంటే ఇప్పుడు క్లౌడ్ ఫ్రాక్షన్ తగ్గించారు పూర్తిగా. కొంచెం జూమ్ చేయండి, ఇంకా జూమ్ చేస్తూ ఉండండి, మీకు ఇంకా క్లారిటీ వస్తుంది. ఆగండి, అక్కడ ఆగండి. అక్కడ ఇదేం లొకేషన్ ఐడెంటిఫై చేయగలరు మీరు? వైజాగ్లో వెళ్తే చేయగలరు. ఓకే, మీకు అది కావాలంటే ఆ లేయర్స్ ఉంది కదా పైన పక్కన అక్కడ ఆ లేయర్స్ మీద క్లిక్ చేసి ఆ ల్యాండ్సాట్ అని ఉందా కింద, దాని మీద అన్టిక్ చేయండి. ఇక్కడ చేయండి సార్, దీన్ని అన్టిక్ చేయండి. చేస్తే ఇప్పుడు మీకు ఊరు పేరు తెలిసింది కదా, ఇప్పుడు మళ్ళీ టిక్ చేసుకోండి. దట్ పర్టికులర్ లొకేషన్ అనమాట అది. సార్ మీరు కొంచెం జూమ్ చేయండి. మీరు సిలోకి వచ్చారు, సిటీలోకి వెళ్ళండి. అదే ఒకసారి లేయర్స్కి వెళ్ళండి. అక్కడ క్లిక్ చేయండి. మీరు ఓవర్ జూమ్ చేశారు, జూమ్ అవుట్ అవ్వండి కొంచెం. ఓకే, ఇప్పుడు మీకు మొత్తం పాత్వేస్ కనబడుతున్నాయి కదా, రోడ్స్ అవన్నీ. ఇది లేయర్స్ క్లిక్ చేయండి. అంటిక్ చేస్తే మీకు పేర్లు కనబడుతుంది. మీరు జూమ్ ఇన్ చేయండి. ఓకే, మరి ఎక్కువ వెళ్ళొద్దు, ఎక్కువ వెళ్తే కనబడదు మనకి. మీరు రన్ చేశారు కోడ్? మీరు ఎక్కడున్నారు? చెన్నైలో ఉన్నారు. అది ఎక్కువ మీరు ఒకసారి మీరు అది రన్ చేయండి, వస్తుంది. మీరు అక్కడ తీసుకెళ్ళిపోతుంది. అది అక్కడ ఉంది. ఇప్పుడు మీకు శాటిలైట్ ఇమేజెస్ని చూసుకోవచ్చు అనమాట, మీకు ఎలా ఉంటుంది అనేది. ఒకటి ఏంటంటే ఈ క్లౌడ్ కవర్ ఎప్పుడు ఉంది, తర్వాత మీరు ఇప్పుడు సపోజ్ మీరు ఎక్కడన్నా ల్యాండ్ కొన్నారు, ఎక్కడో సపోజ్ అనకాపల్లిలోనే ఆడ కొన్నారు, మీరు ఆడ అమరావతిలో ఉంటున్నారు అనుకున్నాం. రోజు పోయి చూసుకోలేరు కదా, శాటిలైట్లోకి వెళ్ళి అక్కడి నుంచి చెక్ చేసుకోవచ్చు అక్కడ ఏమైనా కన్స్ట్రక్షన్ జరుగుతుందా అన్నది. కబ్జా చేశారో లేదో తెలియదు కానీ కన్స్ట్రక్షన్ జరుగుతుందా లేదో తెలిసింది. అలా చెప్పలేము, బోర్డు పెట్టేసినా చాలు కదా. సో మీరేంది చెప్పండి. అది ఫ్రాక్షన్, అంటే 5% మాత్రమే నేను అలౌ చేస్తాను. ఒక ఇమేజ్లో 5% క్లౌడ్ ఉంటేనే నేను అలౌ చేస్తాను. మీరు ఏదో ఓకే, సో ఓకే, నో ప్రాబ్లం.
Sir, that project, see, while selecting project, see, it comes like, but for a project or 50 like that.
No, he kept it my first project. ఒకసారి రన్ చేయండి. సేమ్ ఎర్రరా? ఓకే, ఇది కాపీ చేసుకొని చెప్తాను. కాపీ చేసుకొని చాట్‌జిపిటిలోకి వెళ్ళి అక్కడ పేస్ట్ చేయండి. మొత్తం కాపీ చేసుకొని చాట్‌జిపిటిలోకి వెళ్ళి మీకు వచ్చిందండి? ఓకే, గుడ్. మీరు అక్కడ క్లౌడ్ కవర్ దగ్గరికి వెళ్ళి 5 పెట్టండి. క్లౌడ్ కవర్ అని ఉందా కింద? ఇది క్లౌడ్ కవర్ తగ్గించుకుంటే 5 పెట్టండి. ఇప్పుడు రన్ చేయండి. ఓకేనా? జూమ్ చేసుకోండి. ఓకే, ఐ థింక్ అందరికీ వచ్చినట్లే ఉంది. ఓకే, ఐఎమ్ టేకింగ్ యూ టు అమరావతి నౌ. గూగుల్ ఎర్త్లో కనిపిస్తుంది, మీరు చూసుకోవచ్చు. దీనికి దానికి తేడా ఏంటంటే మనం ఇక్కడ టైం ఇస్తాము, ఇది రియల్ టైం డేటా ఇస్తారు. అక్కడ ఎప్పుడుదో ఓల్డ్ది అక్యుములేట్ చేసి ఉంటుంది, మీకు అన్ని ఆప్షన్స్ ఉండవు. దీంట్లో అయితే మీరు నాకు పర్టికులర్ శాటిలైటే వాడండి, నాకు ఈ క్లౌడ్ ఫ్రాక్షన్ వద్దు అని తీసుకోవచ్చు అనమాట. సైకిల్ అని వచ్చిన టైం చూడండి, మీరు అది ఆ టైంలో పెడితే మీకు క్లౌడ్ కనబడుతుంది. మీరు క్లౌడ్ ప్యాచ్ ఎలా మూవ్ అవుతుంది అనేది కావాలంటే చూసుకోవచ్చు. అంటే మీ ఆబ్జెక్టివ్ మారిపోతుంది అనమాట. క్లౌడ్ ఉన్నప్పుడు మనం ల్యాండ్ కింద చూడలేము, దానికి కావాలంటే వేరే శాటిలైట్స్ ఉంటాయి, మైక్రోవేవ్ శాటిలైట్స్ ఉంటాయి, అవి క్లౌడ్ నుంచి కూడా పెనెట్రేట్ అవుతాయి. ప్రజెంట్ డేటు వాళ్ళు అప్డేట్ చేస్తారు. ఒక్కోసారి ఏంటంటే ఒక ల్యాగ్ ఉంటుంది, ఒక 1 వీక్ 10 డేస్ ల్యాగ్. కొన్ని శాటిలైట్స్ అయితే ఇమీడియట్ అప్డేట్ అవుతాయి. ఓకే, ఇప్పుడు అమరావతి తీసుకెళ్తున్నాను, వైజాగ్ నుంచి అమరావతికి. సో ఇక్కడ ఈ ల్యాండ్ శాట్ ఉంది కదా, ఇది అన్టిక్ చేయండి మీరు. గుంటూరు వెళ్దామా అమరావతి? గుంటూరు, ఓకేనండి. ఓకే, సో ఇప్పుడు గుంటూరుకి వెళ్ళాలంటే మనకి అక్కడ పర్టికులర్ లాంగిట్యూడ్ కావాలి. అది కానీ వస్తే మనం అక్కడ పైన ఎంటర్ చేసేస్తే ఆ ఓవర్ ఆ రీజియన్ మీద వస్తుందన్నమాట. సో మనకి లాంగిట్యూడ్ తెలిస్తే ఓకే, తెలియకపోతే ఏం చేయొచ్చు అంటే ఇటు పక్క కర్సర్ ఉంది చూడండి, ఇక్కడ ఆప్షన్స్, ఇది సెలెక్ట్ చేసుకోండి, మార్కర్ యాడ్ చేసుకొని సెలెక్ట్ చేయండి. తీసుకొని గుంటూరు మీద, మేడం గుంటూరు అంటున్నారు, ఓకే మేము అక్కడ పెడతాము. అంత డీటెయిల్గా కావాలంటే నెక్స్ట్ శాటిలైట్ ఉంది, దానికి వెళ్దాం. ఓకే, ప్రజెంట్ గుంటూరు మీద క్లిక్ చేస్తున్నానండి. ఇప్పుడు గుంటూరు మీద క్లిక్ చేస్తే దానికి సంబంధించిన లాటిట్యూడ్ లాంగిట్యూడ్ ఇక్కడ వచ్చింది చూడండి పైన, 80.44 1630 వచ్చింది. అది ఇక్కడ ఎంటర్ చేసుకోండి. ఓకే, అది ఎంటర్ చేసిన తర్వాత రన్ చేయొద్దు, వెయిట్ చేయండి. ఇప్పుడు మనకి ఇది అన్నెసరీ అనమాట మన కోడ్లో. సో ఏదైతే మనం ఎంటర్ చేసుకున్నామో దాన్ని డిలీట్ చేయండి. ఫస్ట్ది ఇక్కడ జామెట్రీ పాయింట్ ఉంది కదా, దాన్ని డిలీట్ చేయండి. రిమూవ్ చేయొచ్చు, లేదంటే ఆ పక్కన డిలీట్ బటన్ ఉంటుంది, డిలీట్ బటన్ మీద క్లిక్ చేస్తే ఓకే కొట్టండి. ఓకే, మార్చే లాటిట్యూడ్ లాంగిట్యూడ్ వచ్చేసి 80.44 16.3, ఏదైనా పర్లేదు రండి పక్కన. ఓకేనా, అండ్ నౌ క్లిక్ ఆన్ రన్ ఆప్షన్. సో ఇప్పుడు ఇక్కడ చూస్తే మీకు 5% క్లౌడ్ కూడా డేటా వస్తుంది, క్లౌడ్ ఎక్కువ వస్తుంది మనకి. సో దాన్ని తగ్గించుకొని చేసుకోవచ్చు, లేదా క్లౌడ్ని యాక్సెప్ట్ చేస్తానన్నా ఓకే. సో ఇది 30 మీటర్ రెజల్యూషన్ డేటా. సో మీరు అంతకని జూమ్ చేసినా క్లారిటీగా కనబడదు. నేను ఇంకొక శాటిలైట్ చూపిస్తాను, అది 10 మీటర్ రెజల్యూషను. దీనికి దానికి తేడా మీకు కనబడుతుంది. ఓకే, కింద మీకు ఇచ్చిన దాంట్లో పైన వైజాగ్ పాయింట్, వైజాగ్ ఈక్వల్ టు జామెట్రీ పాయింట్ అని ఉంది కదా, అక్కడ ఎంటర్ చేయండి. మీరు కిందాక మార్కర్ పెట్టినప్పుడు పైన కనబడిందా డేటా? ఓకే, అక్కడ చూపిస్తాను అన్నాను. సో ఇదిగోండి, ఇప్పుడు ఈ ఆప్షన్ తీసుకోండి, ఇది మార్కర్ ఆప్షన్ తీసుకొని గుంటూరు మీద సెలెక్ట్ చేశారంటే ఇక్కడ మీకు జామెట్రీ నెంబర్ ఒకటి వస్తుంది చూడండి, ఇక్కడ పాయింట్. అది ఆ పాయింట్ తెచ్చి ఇక్కడ జామెట్రీ పాయింట్లు ఇక్కడ ఎంటర్ చేయండి కింద. ఇది వచ్చిందా, మీరు సెలెక్ట్ చేయగానే ఈ వర్డింగ్ వస్తుంది. మనకు కావాల్సింది మొత్తం అక్కర్లేదు, మనకు కావాల్సింది ఓన్లీ ఆ లాటిట్యూడ్ లాంగిట్యూడ్ మాత్రమే. అది కాపీ చేసుకొని ఈ కింద లైన్లో పెట్టండి. ఇందాక మీకు ఇప్పుడు డిలీట్ చేయాలంటే దీని మీద ఇక్కడ లెఫ్ట్కి వస్తే మీకు ఇక్కడ ఆప్షన్ వస్తుంది చూడండి, డిలీట్ ఆప్షన్ వస్తుంది. దాన్ని క్లిక్ చేస్తే డిలీట్ అయిపోతుంది. ఇమేజ్ ఎప్పుడు ఒక పాయింట్ దగ్గర రాదు, పెద్ద అది శాటిలైట్ స్వాత్ అని ఉంటుంది. 250 కిలోమీటర్ 350 కిలోమీటర్స్ అని ఉంటుంది. అది అంత ఇమేజ్ వస్తుంది. మీకు ఒక పర్టికులర్ పాయింట్ దగ్గర రావాలంటే మీకు ఏం కనబడదు కదా, అందుకని సరౌండింగ్ ఏరియా మొత్తం చూసుకుంటుంది, అంత రేంజ్ వస్తుంది. మీరు ఇప్పుడు జూమ్ చేసుకోండి, అరౌండ్ 300-400 కిలోమీటర్స్ ఎక్స్ట్రా వస్తుంది మీకు. అన్నీ వస్తాయి. ఆ గుంటూరు కవర్ అవుతుంది, గుంటూరు కవర్ కాకుండా మీకు అలా కావాలంటే మీరు దానికి కూడా చెప్తాను. సార్ అడుగుతున్నారు, నాకు అంత బిగ్గర్ ఫైల్ అక్కర్లేదు, నాకు ప్రిసిషన్ కావాలంటున్నారు, గుంటూరు చుట్టుపక్కలే కావాలంటున్నారు. అలా కావాలనుకుంటే మీరు ఏం చేయాలంటే ఇక్కడ ఒక ఆప్షన్ ఉంది చూడండి, డ్రా ఏ రెక్టాంగిల్ అని. డ్రా ఏ రెక్టాంగిల్, మీరు ఆ లొకేషన్ మీ ఏ ఏరియాలో కావాలో ఆ ఏరియా మీద దాన్ని సెలెక్ట్ చేస్తే ఒక ఇస్తుంది, అక్కడ మాత్రమే వస్తుంది ఫిగర్. బట్ కోడ్ మొత్తం మారిపోద్ది. ఆ కోడ్ ఎలా మార్చుకోవాలో చెప్తాను మీకు. సపోజ్ నాకు ఓన్లీ గుంటూరు సరౌండింగ్లోనే కావాలి అంటే ఇది క్లిక్ చేసి ఆ ఏరియాని సెలెక్ట్ చేసుకున్నారంటే ఆ ఏరియాలో ఉన్న గ్రాఫ్స్ పాయింట్స్ మాత్రమే వస్తాయి, మిగతా అన్నీ కట్ అయిపోతాయి. ఇప్పుడు మీకు ఏమవుతుంది, ప్లాట్ చేస్తే నేను ఇచ్చిన పాయింట్ ప్రోగ్రామ్ ద్వారా అటు ఓషన్లో కూడా, బే ఆఫ్ బెంగాల్లో కూడా వస్తుంది, ఇటు పక్క ప్రకాశం డిస్టిక్ అన్నీ వస్తాయి. అంత నాకు అక్కర్లేదు, నాకు ఓన్లీ సెలెక్టివ్ రీజన్ చాలు అనుకుంటే ఇలా సెలెక్ట్ చేసుకోండి. సెలెక్ట్ చేసుకుంటే ఇప్పుడు మీకు అక్కడ పైన ఇక్కడ కోఆర్డినేట్స్ వచ్చినాయి చూడండి, ఇది క్లిక్ చేస్తే మీకు ఇక్కడ పాలిగాన్ అని వస్తుంది. దానికి తగ్గట్టుగా మీరు లొకేషన్ ప్రోగ్రామ్ మార్చుకోవాల్సి ఉంటుంది. ఓకే, ఆ ప్రోగ్రామ్ మార్చుకోవాలంటే ఎలా చేయాలో చెప్తాను. మీరు ఈ ప్రోగ్రామ్ మొత్తం కావాలంటే ఎలా చేయాలంటే చాట్ జీపీటీలోకి వెళ్ళండి. చాట్ జీపీటీలోకి వెళ్ళి అక్కడ సింపుల్ కమాండ్ ఇవ్వండి. దానికి ప్రాంప్ట్ ఏమని ఇస్తారంటే, మీకు ఆల్రెడీ ఈ కోడ్ ఉంది కదా, ఈ కోడ్ కాపీ చేసుకొని చేంజ్ ద కోఆర్డినేట్స్ టు కోఆర్డినేట్స్ అరౌండ్ గుంటూరు latitude with plus or minus 5 plus or minus 1 degree. ప్లస్ ఆర్ మైనస్ 1 డిగ్రీ. సరే కోడ్ మర్చిపోయింది రాయటం. మీరు అది అడగగానే మీకు ఇక్కడ కోడ్ ఇచ్చింది చూడండి, గుంటూరు ఏరియా. ఈ మాత్రం కాపీ చేసుకోండి. నాగార్జున సాగర్ అది డేటా క్వాలిటీ తక్కువ ఉంది. ఇది ఓన్లీ 30 మీటర్ ఉంటుంది రిజల్యూషను. నేను ఇంకో శాటిలైట్ బాక్సెస్ వస్తున్నాయి. అదే జూమ్ చేస్తున్నారు కదా, అది అన్ని చోట్లకి యాక్సెస్ కాదు. యాక్సెస్ అంటే 30 మీటర్ మాత్రమే ఉంటుంది రిజల్యూషన్. మీకు అక్కడంతా ఇది కదా, డ్యామ్ ఉంది కదా, ఆ డ్యామ్ మీద మొత్తం అంతా యావరేజ్ చేస్తుంది. అందుకని మీకు జూమింగ్ చేసినప్పుడు కరెక్ట్గా కనబడదు. అలా ఏం చెప్పలేం, యూజువల్గా అలా ఉండదు. సో ఇప్పుడు ఇది చేంజ్ చేసుకొని సార్ రన్ చేసుకొని చూద్దామనండి. ఓకే, ఇవ్వండి సార్. ప్రాబ్లం ఏంటంటే మీకు ఆ టైంలో ఇది జామెట్రీ, బట్ ఇక్కడ వచ్చింది మీకు సిగర్, ఆ స్వాత్ ఇక్కడ ఉంది. సో ఒక్కోసారి మీకు కరెక్ట్గా ఉండదు స్వాత్, అందుకనే మొత్తం లాంగర్ ఏరియా తీసుకుంటాం మనం. సో ఇప్పుడు మనకి ఎక్కువ టైం లేదు, ఇంకో 10 మినిట్సే ఉంది. సో నేను ఇంకొక శాటిలైట్ చూపిస్తున్నాను, చూడండి. సెంటినెల్ శాటిలైట్ అని, ఇది మీకు కవరేజ్ హై రిజల్యూషన్ కవరేజ్ 10 మీటర్స్ రిజల్యూషన్ ఉంటుంది. ఫస్ట్ మీకు ఇచ్చిన వాటిలో లాస్ట్ స్లైడ్లో ఉంది ఇది ఇన్ఫర్మేషను. ఆ డేటా తీసుకొని ఒకసారి ఆ ప్రోగ్రామ్ తీసుకొని రన్ చేస్తే మీకు ఓవర్ ఢిల్లీ కనిపిస్తుంది. ఢిల్లీ లొకేషన్లో కోడు ఢిల్లీ లొకేషన్కి రాస్తున్నాం మేము. సో మీరు జూమ్ చేసుకున్నారనుకోండి మీకు క్లారిటీగా కనిపిస్తుంది. ది లాస్ట్ స్లైడ్లో ఉన్న కోడ్ తీసుకొని ఇంకొక విండోలో ఓపెన్ చేసి సెంటినల్-2 అదే శాటిలైట్ మారుతుంది. ల్యాండ్సాట్ 8 ఓల్డ్ శాటిలైటు అది వచ్చేసి 30 మీటర్ రెజల్యూషను, సెంటినల్ వచ్చేసి 10 మీటర్ రెజల్యూషన్ ఉంటుంది. ఇప్పుడు మీరు ఏం చేస్తున్నారు మీరు ఇప్పుడు? ఇంకొక విండో తీసుకోండి, ఇంకొక విండో తీసుకొని లాస్ట్ కోడ్ తీసి అక్కడికి పేస్ట్ చేయండి. ఇది న్యూ ఢిల్లీ, ఇది చూసుకోండి. ఇప్పుడు చూస్తే ఎంత జూమ్ చేస్తే ఎంత క్లారిటీగా ఉందో. సో ఇప్పుడు నేనేం చేస్తానంటే వైజాగ్కి తీసుకెళ్తాను. ఇందాక వాడిన వైజాగ్ లాటిట్యూడ్ లాంగిట్యూడ్స్ ఉన్నాయి కదా, వైజాగ్ లాటిట్యూడ్ లాంగిట్యూడ్స్ చూపిస్తాను, మీకు క్లారిటీ వస్తుంది. ఒకటి 6th స్లైడ్లో ఉన్న లాటిట్యూడ్ లాంగిట్యూడ్ పెట్టండి. ఓకే, నేను చేంజ్ చేశాను లాటిట్యూడ్ లాంగిట్యూడ్. ఇది ఓవర్ వైజాగ్. ఇందాక చూసిన ఇమేజ్కి తేడా కనబడుతుందా లేదా? ఇంకొకటి ఏంటంటే అది వచ్చేసి 2000 టైం ఎప్పుడు ఉంది, 13, అది 20, ఇప్పుడు వచ్చింది 2023 నుంచి వచ్చింది. ఇది లేటెస్ట్ డేటా. సో ఇప్పుడు జూమ్ చేశారనుకుందాం, ఫర్ ఎగ్జాంపుల్ ఢిల్లీ కాదు వైజాగ్కి మార్చాను. ఇప్పుడు నేను వైజాగ్ లాటిట్యూడ్ లాంగిట్యూడ్ పెట్టాను. సో పెద్ద మడక ఇందాక చూపించాను కదా, పెద్ద మడక దగ్గర ఒక రిజర్వాయర్ ఉందని, సేమ్ రిజర్వాయరు ఇందాక ఇమేజెస్కి ఇప్పుడు ఇమేజ్కి తేడా చూడండి. అదే మీకు రిజల్యూషన్ మారటం వల్ల మీకు క్లారిటీ వస్తుందన్నమాట. ఇది సెంటినల్ డేటా నుంచి సేమ్ మీరు ఇందాక చేశారు కదా దాంట్లో వైజాగ్కి, అక్కడ వచ్చేసి మీకు సో ఈ ఇమేజ్ వచ్చేమో మీకు ల్యాండ్సాట్ నుంచి, ఇది ల్యాండ్సాట్ ఇమేజ్. నేను జూమ్ చేస్తున్నాను, ఎంతవరకు వెళ్తుందో చూద్దాము. సో క్లారిటీ పడిపోతుంది ఇక్కడ. అదే రెండోది వచ్చేసి మీ సేమ్ సెంటినల్ డేటా నుంచి జూమ్ చేసారనుకోండి, లోపల ఉన్న అండర్ పాస్ కూడా మీకు పాత్వే కూడా కనబడుతుంది మీకు క్లారిటీగా. అదే దీంట్లో అయితే మీకు అక్కడ చూడండి, క్లారిటీ చూడండి. అవును, కాకపోతే ఇక్కడ పిక్సెల్ సైజ్ చూసుకోండి, మీకు ఒక్కొక్క ఇమేజ్లో ఉండే చిన్న సైజ్ ఎంత మటుకు వెళ్ళగలం దాన్ని పిక్సెల్ అంటాము. ఈ పిక్సెల్ చూస్తే ఇక్కడ బ్లర్డ్ అయింది, ఇది మ్యాక్సిమం నేను జూమ్ చేయగలను, అంతకన్నా ఎక్కువ పోతే అసలు పిక్చర్ కనబడట్లేదు. అదే దీంట్లోకి వెళ్తే చూడండి ఎంత క్లారిటీగా ఉందో. ఇక్కడ కూడా బ్లర్ అయింది, బట్ ఈ లెవెల్లో చూస్తే మీకు క్లారిటీ కనబడుతుంది. సో అదే లెవెల్లో ఇక్కడికి వెళ్ళి చూశాను అనుకోండి, ఇమేజ్ క్వాలిటీ ఏది బాగుంది? సెంటినల్. ఇది ఇంకా జూమ్ చేసింది, ఇంకా జూమ్ అవుట్ చేశాను అనుకోండి ఇంకా బాగుంటుంది మీకు క్లారిటీగా. సో సపోజ్ ఇప్పుడు మీ ఇంటికి చూసుకోవాలనుకుంటే ఒకసారి మీరు చిన్న ఎక్సర్సైజు అది తీసేసి, అది ఉంది కదా మన మార్క్, ఈ మార్క్ తోటి మీ పర్టికులర్ లాటిట్యూడ్ లాంగిట్యూడ్ పెట్టుకోండి, మీ ఊరిది లాటిట్యూడ్ లాంగిట్యూడ్ పెట్టుకొని రన్ చేయండి సెంటినల్ 2 తోటి. సరౌండింగ్ ఒక స్వాత్ వస్తుందండి, 300-500 కిలోమీటర్స్ వరకు వస్తుంది డేటా అవైలబిలిటీ నుంచి. అది ఇందాక చూపించాను కదా, మీరు ఒక గ్రిడ్ పాయింట్ పెట్టుకున్నారంటే ఆ ఏరియా మాత్రం చూపిస్తుంది. బట్ మీకు ఎక్కడైతే సెలెక్ట్ చేశారో అక్కడ డేటా లేదనుకోండి మీకు ఎంటీ కనబడుతుంది. అందుకని యూజువల్గా మేము చూపించేటప్పుడు ఒక పాయింట్ ఇచ్చేస్తాము, సరౌండింగ్ మొత్తం తీసుకుంటుంది. కావాలంటే జూమ్ చేసుకుంటాం. ఇప్పుడు ఈ సెంటినల్ ప్రోగ్రాంలో మీ లాటిట్యూడ్, మీ విలేజ్ లాటిట్యూడ్ లాంగిట్యూడ్ పెట్టుకోండి, లేదా మీ వీధి అయినా పెట్టుకోవచ్చు, కరస్పాండింగ్ స్ట్రీట్ మీ హౌస్ అయినా చూడొచ్చు. అంటే హౌస్ చుట్టుపక్కల కాలనీ. ఓకే, ఇక్కడ ఇంకో చిన్న పాయింట్ మీకు, ఇక్కడ జూమ్ చేసినప్పుడు ఇక్కడ ఒక వాల్యూ వస్తుంది చూడండి, 200 మీటర్స్ అని. అది ఎంత రెజల్యూషన్ అదో చూపిస్తుంది అనమాట. 200 మీటర్, 500 మీటర్స్, ఇది 500 మీటర్స్, ఇది 500 మీటర్స్, రెండు 500 మీటర్ రెజల్యూషన్లోనే ఉన్నాయి మీకు. అంటే 500 మీటర్ ఆల్టిట్యూడ్ నుంచి చూడండి ఏది క్లారిటీ ఉందనేది. గుంటూరులో మీకు క్లౌడ్ ఎక్కువ ఉంటుందండి. క్లౌడ్ 5 పెట్టుకోండి.
networks. So to the orange we can feed in this data, we can train the neural network. Once we train the neural network, we can predict some of the properties. That's what we'll do actually in these projects. So first thing is about the protein structure prediction, because as somebody was saying, we need to know the protein structure to at least to design the drugs, right? Because we cannot throw a drug into your body, because the drug can be a poison. Okay, because we have to design the drug in such a way that it will go and inhibit the proteins, okay, so that it will kill the disease, right? So knowing the structure of the protein is very, very important actually. So for that, first what we'll do is we'll check in our common databases actually. One of the databases is PDB database. How many of you are aware of these databases, PDB databases? No, not aware of this? Okay, we'll see actually what is PDB databases. So if the structure is not available in PDB database, what is the solution? How we can do a structure, how we can do a drug designing, okay? So without knowing the target protein structure, we cannot do a target based drug designing. So we need to know. So if there are no structures available, what we'll do is we'll rely on some of the theoretical methods available freely in the web. Okay. So one of the method is called AlphaFold. Okay, we will visit the AlphaFold website. We will feed in some of the amino acid sequences. Then we'll see what AlphaFold is generating for us. Okay, then we will compare that AlphaFold, whatever we predicted from the AlphaFold, with the actual one. Okay, for that what we'll do is we'll take a known protein itself. Okay, from the literature. Okay, that's what we'll do is. And in the third one we'll do a retrosynthesis. I'll just explain you the idea actually, because retrosynthesis is a lot of programming we need to know, because we need to learn a lot of, because basically neural networks is for learning actually, learning the patterns. So if you want to learn means learning a reaction, it is very hard problem actually. So we have to write the code in such a way that it will learn all the different types of reactions. Okay, once we learn all the elementary reactions through our neural network, that we can use it for retrosynthesis actually. I tried to get some of the software, but none of them are working actually. Okay, I tried so many things, but nothing is working. But if you want to bring it to the Orange platform, it's a hard process. But I can tell you the idea, what we can do in the retrosynthesis. Okay, and the last one is about the material design. So material design is again generating new materials with the new properties. Okay, so there are so many materials. People are already worrying about solar energy materials. Okay, hydrogen storage materials. These are all there with certain efficiency. But how we can come up with the new materials with the new properties? Okay, there are superconducting materials. Okay, we want high-speed trains, but we don't have superconducting materials. So if you can generate superconducting materials which are working in a room temperature, then well and good actually, right? It is very cheap. We can have super fast trains everywhere actually. Okay, but since so that's why what we'll do is we'll try to understand the current state of the art actually. Okay, first thing is about the protein structure. Okay, so there are different varieties of algorithms in the literature actually for protein structure again. Okay, so first thing is to get the target protein. Okay, first there are two entities in the protein drug designing. For the physicist actually I am telling, because there are two entities in a drug designing. One is the target protein, and we send some drug molecule. That is the goalie that we take actually. We send some drug molecule to the target protein so that it will bind to the target protein, so that it will denature or it will inhibit the property of the protein. Okay, so that's what we do in the drug designing process actually. Theoretically also we have to do the same thing actually. So in the theoretical process, essentially we have to look at the binding energies between the drug and the target protein. So since it's a machine learning course actually, I'm not going to discuss about any docking process actually. Docking you have to learn yourself. Okay, so first thing is about getting the target protein. So target protein, there are freely available databases are there. One of the database is PDB database. If you go to your browser, just type PDB database. Okay, and along with this we need another package. You can download Chimera. Go to another tab, just type chimera, CHIMARA, sorry, chimera, MERA, chimera download. Yeah, just go to the Google, then type PDB database, see the first one. Okay, so this is a database, it's a freely available database. This particular database stores all the protein structure in the world actually, whatever people have synthesized till this point. Okay, so this is a database that contains the protein database. Another thing that we need is to visualize this particular protein, whatever we are going to download. Okay, we need a package called Chimera, CHIMERA, download for Windows. Okay, just download the first one. So there is a exe file. Just click on the exe file, it will automatically get saved. And here at the end, you just say accept. Okay, let it download in between. So the way to work with the PDB database is like okay. Is it downloaded? Okay, so in the PDB database, you just type 1L2Y in this search space, because we'll be worrying about only the smallest protein actually, one of the smallest protein, that is this TRP cage molecule protein. Okay, so this is a place where you can search any protein in the database. Okay, enter the search term. You can either just type a TRP cage protein also you can type. Otherwise, every protein is having a special name. So that is four letter label actually, 1L2Y. You just type 1L2Y here, just say search. Then you come to this particular website. Similarly, if you want to search any other protein, maybe suppose if you want to download COVID-19 associated protein, just type COVID-19. Otherwise, if you want to have some target protein which is associated with cancer, type cancer here. Just type cancer, you will get a lot of list actually. From there you can download. Yeah. Format we'll see. Yeah, format we can download PDB file. Okay. So the way to download, once you type 1L2Y here, this will go to this particular protein. So this is the protein. Here itself, I think you can rotate. It's not working. Okay. So here, from here you can download either a PDB format, otherwise zip format, otherwise FASTA sequence. Okay. You can download PDB format. What is it? Download file. Okay. Download, you say PDB format. Okay. Okay, whatever the Chimera you downloaded, the package, got it? So you can download the file in PDB format. Okay, so there is a legacy PDB format, and there is also something called FASTA sequence. Okay, because this FASTA sequence is important because when we go to AlphaFold. Okay, so this is one of the way to get the protein structure. Directly go to the PDB database and just let us visualize this particular protein through Chimera, because these are freely available packages. At home also you can download this, you can use it actually. Okay, so Chimera, yeah, just double click on the exe file whatever you downloaded. Here you downloaded exe file, sorry, here, just double click on this, then you can install the Chimera in your local machine. Just say yes, next, I accept, next, next. Would you like to install because it's already there? So I say no. Okay. Everybody installed Chimera? Just try, it is fun actually. Okay, at home also you can try. Could you able to download the PDB file? Yes, download file here. Yes, PDB, legacy PDB format. Just try. I accept the agreement. Upload legacy PDB. Down. Yes. Which one? Skip the activation. It's already open, no? Because PyMol is already installed in your machine. In some of your machine, PyMol is already installed. Okay. There are so many packages. Okay. We are just discussing only few. Chimera. Yeah, just go to file in Chimera. Chimera, just double click, just say yes. You're not trying? No. It's ready. Okay. Fine. In Chimera, if you go here, if you go to file, just say open. Place to okay, if you go to file and say open, go to file, sorry, If you just go to file, just say open, you can open the PDB file. So this is a way we can visualize these PDB files of the proteins. Okay, and we need to download one more format for the smallest protein. So sir, you just go to open the Chimera after you install, go to file, say open. Otherwise you can just open Chimera, just drag your PDB file into Chimera, automatically open. Okay, just close this, just say Chimera from here, Chimera. Not working?
Showing only desktop only.
You can go to backslash.
Only highlight saving the file on the desktop.
What is it?
Highlight only access the file.
By default,
Change the directory. Change the drive here. Just go to D. Wherever you. Okay. I saved in D. Then within this set of folders, you can see the file. Okay. Just go to file, say open, just change the drive. If you are saving C, go to C. If you are saving D, save in D, wherever actually. I am saving in D. In D, you can see all the folders. If you are saving in some folder, just go to that particular folder, here suppose. Then you can see the content here. Just select it, just say open. That's it. Okay, so we need to download one more format called master sequence. So this master sequence contains the collection of amino acids within this protein. Okay, so this master file also has an extension .pasta. Over here, you can maybe open in a notepad. These are the set of amino acids which are there in this particular protein. Okay, so here this label for this protein is 1L2Y, and the corresponding amino acids within this particular protein are these. The second line. Yeah. So from the PDB database, you need to download two things. One is the PDB that you already did. Hope you already visualized the PDB through Chimera. Okay. The second thing that we want is the master sequence. Master is a special sequence, so it mentions only about the amino acids within that particular protein. Okay. So if you go and automatically it will download in your download folder. Go there and open in a notepad. In the notepad, the first line of the content is the label corresponding to the protein. There is 1L2Y. Okay, and the second line onwards, it will display the amino acids within that protein. It will display only the first letter of the amino acid. Is that okay? Hope you are done. Have we completed this master sequence? Okay, we just need this master sequence for the alpha fold, because we'll directly go into the alpha fold website. There we have to feed the information in master format. to find. Open. Here, same size. Complete, yeah? So everybody got the FASTA format, FASTA sequence? Okay. So this is a known protein. For the known protein, the coordinates are available actually. Okay. Coordinates are available, and once the coordinates are available, we know which are the amino acids in that particular protein. And these are the labels which tells us which are the amino acids in this particular protein. Okay. So if you directly know so if somebody would have reported the target protein, then it is very easy to do drug design. Because directly we can go to the PDB database. From there we can download the target protein molecule. Then on that particular target molecule we can start designing drug molecules. That is a very easy thing. Okay. Now the thing is, if you don't have any protein structure which is reported in literature, suppose the disease whatever you are going to work is a very novel disease and the targets are not known. Okay. How do we handle those cases actually? To handle those kind of cases actually, we have to rely on some of the computational methods for protein structure prediction. Okay. As we discussed in the last class actually, AlphaFold is one of the known standard method actually. People accept that particular method. Even in journals also, if you have done the protein structure prediction using AlphaFold 3, then no issue. Okay. Usually the referees don't counter ask too many questions. Okay. But if you are relying on some other theoretical method, then you have to verify actually, you have to prove whether it is right or wrong actually. But AlphaFold has got that much of confidence to say that okay, it can predict the protein structure almost like almost like 95% to 99%. Okay. Now how we can make use of this AlphaFold to predict protein structure? Okay. Okay. So PDB database is about protein targets. Okay. So once we have the protein targets, basically we want to employ machine learning for our drug design, right? So for machine learning, we need to learn the patterns, how a target protein is interacting with the drug molecules. There are so many drugs in the markets, right? So we have to find which are the drugs which are there in the markets. Where do we get it actually? We have to rely on some other database for these small molecules. Okay. So another database, one of the known database is PubChem is there actually. PubChem is a small molecular database. It's not like a protein database, not like a large molecular database. PubChem is a small molecular database. Okay. So the way to go to PubChem is like you can go through the browser, just type PubChem in Google. You you can go to PubChem. There also you can search the molecule using just by drawing the molecule. Otherwise, you can write the name of the molecule, whichever way. Just say search. It will give a lot of information. This is one of the database actually, PubChem. Okay. Just check it actually in your browser. PubChem. It's freely available database, and this PubChem has a molecule along with the corresponding lot of properties are also available in this database. Okay, whatever the experimentally known properties, physical properties, that is also documented in this particular database. Okay, another database called ChemBell. Okay, it's called ChEMBL actually. So people call it as ChemBell. So in this ChemBell also, if you go to the ChemBell database, there also is meant for small molecular database. These are not meant for protein database. These are only meant for small molecular databases. Okay. So even in ChemBell, if you go from the browser, can you go to the ChemBell? So we have to download something from the ChemBell database. In your browser, please type ChemBell. Yeah, PubChem, whatever the white space you are seeing, white, yeah, just on the white space, type it, type something, code or whatever, okay, some. Okay, in the ChemBell also you can see a very wide space where you can type and search for the drug molecules. So I want you to search one of the drug molecule, okay, that is called aromatase. That is the spelling, aromatase. This is a drug related to breast cancer actually, okay. This is one of the drugs that blocks the conversion of testosterone to estrogen actually, okay. So this essentially go and bind to the target protein, and it will disturb the protein, and it will deactivate the enzyme, and it will block the corresponding reaction from of testosterone going into estrogen. If you produce more of estrogen, then it may lead to breast cancer kind of diseases actually. So this is one of the target drug molecule actually. So, sure. Yeah. Click on that. Okay, so once you search the aromatase, okay, what you can see is, once you search, suddenly it will not pop up in the web window. Just scroll down. Okay, just scroll down, little bit down. Can you see any molecules in the screen? Yeah, just type ChemBL 1978. That also you can do. Yeah, everything capital, ChemBL. Scroll down. Can you able to see IC50? Okay, so if we just type this Chem Bell 1978, then you see there is a target at the bottom. If you select this one, just select that, it will go to aromatase. Okay, then if you scroll down, you can see so many molecules, so many drug molecules. Okay, you can also change the number of molecules which are reporting in one page. You can go up to 20, it says 20, sometimes it may go up to 100 also. Let's say 20. See, you can, in one shot, you can see 20 molecules. Okay? Yeah, just take only 1978. Yeah, once you type this Campbell 1978, scroll down, then you see the target here. Okay, at the target here, here you click. Here only you click. Okay, just type Campbell 1978. Then at the target, please click here. This is for structures. Okay, click here. Then it will go to this site. Here you can change items per page. You can make items up to 20 in the page. Okay, so in the total database, it is showing something like 7022 molecules, okay, which can inhibit this particular target protein. Can you see, if you scroll down at the bottom, you can see 7022. So these many drug molecules that can inhibit this particular target molecule. Okay, now these are the distribution actually, because there are so many information other than structure. Okay, we need to have one very important information in drug designing, that's called this affinity. Okay, this is the affinity of this target molecule with the protein. So the affinity is defined by this IC50 value. Okay, so there are many proteins, there are many small molecules for which the IC50 is not available. Okay, if you want to train your neural network with this data, you need to have this IC50. Okay, so if you want to have data only with IC50, click on that IC50. Okay, this is very important. Then you can start seeing a lot of drug molecules below. You need to be very careful while clicking. That IC50 value is very, very important. I can show you once again. The Campbell data set, you already got this aromatase in the last page, and just scroll down, then there is a pie chart at the end of the page. Okay, this pie chart will tell you what is the distribution of the data within this data set. Okay, So there are many small molecules for which these IC50 values are not reported. We cannot take it actually because IC50 value is a deciding factor that decides the activity of the drug molecule. Okay. So what we do, we will not take those molecules. We will take only the molecules for which the IC50 values are reported. So if you want to select those molecules out of the 7,022 molecules, totally there are 7,022 molecules. We will not go and directly take everything because most of the molecules don't have this IC50 value. Okay, so just click on this IC50, then your database will get refined automatically. Click here. Okay, so you got a new page where you have the structure, you have the corresponding IC50 value. Can you see the molecules? See, these are the IC50 values. Okay, so these many molecules are having IC50 values. So that is very, very important. So now, hope you got it. So this is in the website. We just scratched out the information. Now we have to get this one for our orange package. Okay, let us get the data. So we have to download it as CSV file. Are you seeing at the top of this website? Okay, above all the list of the small molecules. Yeah. Yeah, basically IC50 value talks about the druggability of the molecule actually. Okay, there is a definition for IC50 value. 1 minute, I'll show you the definition. Yeah, basically it's the concentration of the drug molecule that is required to deactivate the target protein by 50%. Okay, initially the target protein is having activity and it's the amount of concentration of the target drug molecule that is required to deactivate the target protein. So if the concentration is less, means it is highly active. Okay, if the value is large, means we need more concentration of the small molecule. Okay, that's the meaning of it actually. It's an experimental value. Yes, it's an experimental value to quantify the activity of the drug molecule. Okay. Yes, just click on this CSV file. Okay, before going there, okay, hope you were able to download that CSV file. So that will contain, in one shot you can download the entire database into your machine. Okay, you don't have to worry about each and every entry. So whatever the molecule which is shown here, whatever the molecule we filtered, whatever is visible in this particular site, okay, here just go and just say CSV download. Automatically all the molecule and the corresponding properties will be downloaded into your machine. Okay. Now, coming back to our protein structure prediction actually, okay, we started by saying first we will do the protein structure prediction, then we started worrying about the databases. Okay, so now we are familiar with two of the databases. One is for the protein PDB database, another is for the small molecular database Campbell, right? So the formats are different. For the protein we save it in a PDB format, okay, and for the small molecule we save it in CSV format. CSV is an Excel sheet basically. CSV means comma separated values. Okay, these are very familiar data type for machine learning. during your previous class also you might have dealt some data in CSV format. CSV means comma separated values. These are entries in columns. Okay, every entry is separated by a comma. That's what it means actually. Otherwise, it may be separated by a semicolon. Otherwise, it may be separated by just space. Okay. So since you know the target protein, okay, now we will first do our first task actually. We will go and find the structure of our known protein through the AlphaFold. Okay, AlphaFold is one of the known server by which we can find the structure of any unknown protein. So what is required for this one actually, for AlphaFold? So if you in Google, if you go and type AlphaFold 3, because there is a current version of AlphaFold, just go to Google, just open another tab. Yeah, if you just type only AlphaFold, it will take you to some other website. Type AlphaFold 3. Okay, just go to Google. Just type AlphaFold 3. Okay, enter. AlphaFold server. Okay. So here important thing is, any confusion? Important thing is you need to sign in here if you want to use this server, because this is somewhere in US kept US. So if you want to access this their service, you have to log in with something. You can, in the easy way, you can log in with your Google account. They will accept. Okay. Just click say continue with Google. Just say continue with Google. Okay, so here you can see certain information about what you can do with this server. Okay, so here this server basically you can freely avail this service for predicting only 30 more protein structure. Okay, not more than 30 in a day. So here I tried one in the morning actually. That's why my number is only remaining is left only 29. So yesterday I tried another 2. So every day you will get a chance of predicting protein structure of almost like 30 molecules you can submit. Okay, and here you can submit a job up to a protein of 5,000 tokens. So this token means the number of amino acids in a protein, right? So we know proteins are a collection of chains of amino acids connected by covalent bonds. So what is required for this particular server is the collection of amino acids in the sequence. Whichever the sequence you want to predict, you have to give that particular sequence to this particular server. Okay, and there are so many information in this particular website. Whenever you are free, you are free to go and read it. But for our class, we don't need most of it. Okay, if you go to this FAQ and guidelines, see, you can get a lot of information about this particular site. What are the things it can do? Okay, all those things. Okay, it can do many things now. Very simple. You can do many things. Maybe you can publish also. You can work on drug design. You can publish on protein-protein interaction, protein-drug interactions, RNA-protein interaction. Many things you can do with server actually. I'll just show you one thing. Okay. Now in this particular website, what is required actually to predict the protein structure? Okay. Here, when you go again, come down a little bit. Okay. These are all the information. Here you can. The AlphaFold 3, as I told in the last class, you can predict the structure of proteins, unknown proteins. You can also predict the structure of DNA. You can predict the structure of RNA. You can predict drug target complexes. Okay, it will predict the structure of the drug target complexes, and also it will predict combination of these. If you give a protein molecule with a drug and an ion, okay, it will automatically predict the optimum structure of this protein, drug and the ion. Okay, you can define it actually. So we'll start with a very simple thing. We'll just start with the protein. Just select protein here. Okay, number of copies only one, input. So in this input, we already downloaded the information. What we will do is we will not go and dump 5,000 amino acid change actually. We'll take only the smallest protein, whatever we did in the previous this one. Where is it? Yeah, 1L2Y. Okay, this is the smallest protein, which is almost like 13 or 20 amino acids. Okay, 20 amino acids. So what is required for this alpha fold is the FASTA sequence. So FASTA sequence you already downloaded. Just go to this download file. You downloaded the FASTA sequence. You just open that FASTA sequence in a notepad. Where is this notepad? So this is a notepad. As I told you, the first line corresponds to the protein name and the other details. Okay, the second line onwards, you will start giving the information about the amino acids. Just copy paste everything. Copy paste all the amino acids within that particular amino protein. Just Control C, select, and just say Control C. Otherwise, you select it. You just go to Edit, say Copy. Okay. Then come to the website, AlphaFold. Okay. Here, this input, the website is waiting for your information. Just click on Input. Here, just do a Control V. Just paste the sequence. Okay. Whatever the information we got from FASTA sequence, we are just dumping it. Say save the job. Okay. Don't do anything actually. Okay. Save the job. Okay. Continue and preview the job. So can you see in the website itself? Don't worry. Okay, just say continue and preview the job. What happened? Yeah, again, just say save the job. Okay, job saving pending. Okay, job saved successfully. Something will come in on the top here. Okay, just say continue and preview the job. Can you? Okay, if you say that, say confirm and submit the job. Again, one more window will pop up. Say confirm and submit the job. Job successfully launched. Okay, if you want to see you have launched the job, you can see the date and time. See, so whatever the job which is already completed is visible. There are some of the jobs which are already completed. I did it on 11th March. I did it something on 13th. Okay. Today again I did it at 12 o'clock. See? And these are the ones ongoing, and these are the ones already done. Okay. When you submit, you can see the status. Have you submitted? Okay. Just wait for a few minutes. At home you can try. Here don't try. When you are free to submit up to 30. Okay, you try small ones actually. This I am just telling for the class. Okay. Okay. Yeah, that's what we'll do it actually. Okay, you want to do it, right? Okay. See here. You come here. Here you have already the protein. Okay. How will you do experimentally? Trial and error, right? You have to ask God only actually. As a chemist, we do trial and error, right? Here, so if you want to know the structure, if you are very specific, your drug molecule, your target protein, then if you that also you don't know, right? What may be the structure? Where the drug will go and bind in the target protein? That we don't know, right? So if you want to, if you synthesize the drug, and suppose if you if you synthesize the drug, you are sure that it may work for, it may act as a cancer drug, suppose. Okay, then you search for the cancer target. Search for the cancer target. Okay. Yes. From the PDB database, get the protein sequence in the FASTA format. Okay. So you got the target protein sequence. Come to this website. paste it here. Okay, paste it here. And along with that, there is one more thing, add entry. Okay, add entry. So here, what you're going to do, you're going to paste your ligand. Can you see the ligand? Ligand is your organic molecule, whatever you synthesized. Okay, okay. From here, you can do many things actually. Just say suppose if you want to put a ligand as ADP, okay, or ATP suppose. Just select it. You type it out also, okay. Then say save job. Okay, save job. Now you have your target protein and your synthesized molecule. You can check it theoretically. Okay, computationally it will verify. Okay. Say save job. Job successfully saved. Continue and previous job. Confirm and submit the job. Okay, job successfully launched. So that's also going on. Okay, there are so many pending jobs now. Okay, once the job is complete, I just took for easiness, I took the previous protein itself. Ligand I gave the name here. Here. Yeah, from the list I just, for easiness I just took some ligand. Okay. You can give it that. You can give it actually. You can add it actually, but the ligand doesn't have a limitation, I think. Yeah, zinc. Yeah, right now I am not seeing an option actually to put your to paste your drug molecule. I think from the template, maybe out of similarity, you can use some of the molecules actually. If some of the molecule whatever you are synthesizing is similar to any of these molecules actually, maybe you can use it actually. You can check it. Okay. So is any of your jobs over? Now, once you complete your job, you can see the tick on your submission. Okay, here itself we can see the molecule. See, can you see the fastness of this particular method actually? How fast they predicted protein structure? They never went and solved Schrodinger equation to get the structure, right? Because it's like some of our smart students, right? Some of the students, they study ab initio, they study everything, then they'll write exam. But some of the smart ones, they will not study, they will make use of whomsoever studied, right? So this is by out of similarity search actually, right? So when we have given as protein, what the website done is the search for similarity within the literature. Okay, so patch by patch they come up with the structure. Okay, so here amino acid sequence from here to here is already known actually. Okay, it's already known in the literature. This entire structure is already known. That's very very pakka we can say. But if the protein structure is not known in the literature, it will patch. It will do a patching up. Okay, so it will search for the sequence of amino acids which are already there in the literature. Maybe the sequence may be in human beings, it may be in cats, it may be in dogs, it may be in birds. It will search the sequence in all the animals. Okay, and for those sequences, if the structure is known, it will take from there. Okay, and from our new protein sequence, again what it will do is it will start searching for the dimer interaction, amino acid interaction, and it will do a minimization actually of the interaction. Then it will come up with the final structure actually. Okay, so patch by patch it will predict the protein structure. It won't directly go and do any dynamics or anything, but it usually learns the data which are already there in the literature. Okay, so there is an enormous data which is attached to this particular website. So they go and search in the database which part of the amino acids are already there in the literature in the database. From there they get information. So they get information about the patches. So the patches they put it together, they come up with the final structure. Okay, so when you look at this particular protein structure, what you can see is this is with a high PIDDT value actually. Okay, this is with a high confidence. They are saying, okay, this is the highly predicted protein part actually, but there are certain dangling region of the protein which may be flexible. Okay, for that the confidence level is less. Okay, so there is a scale here. So the dark blue is with high confidence, and with the light one is with less confidence, and yellow one is again less, and the orange one is least one. So for this particular protein, there are no yellow and orange region. We have only blue and light blue. So the blue is very highly confident. The prediction is highly confident. Okay, and the light blue is something like a dangling region of the protein. That is with the less confidence. We'll go. Okay, so this is one of the submission I did early morning today. So at 6:18 you can see the time. Okay, so I just added the structure will change because metal ion has a strong interaction with the target protein, so that will deactivate. Even this also, see, when the drug when one of the target molecule acted on the protein, so the dangling region got extended. Okay, so it will disturb. It should disturb. That's the whole part of drug design. Green region. This is a aligned residue and this is a scored residue. There is a scale actually. Expected position error. Here, okay. This is talking about yeah, actually these amino acids are numbered from 1 to 20. Here, okay. Yeah, okay. Yeah, because the ligand I selected is NAD and the protein I selected is the same old protein. But we are finished now. We'll finish, right? Okay. Then we'll go. Okay. Okay. So that is about one of the thing actually. Okay. So here we can predict the protein structure. Another very important thing that I want to discuss about is about the materials. Structure, right? We can download the files. Okay, you can download the files. Yeah, we can get the descriptors, tools. We can do a sequence analysis. In Chimera we can, yes. We can compare, yes. We can download the folder. Structure analysis. Sequence match alignment. Where? Action is only for seeing the bonds and everything actually. We can compare the two proteins actually using this 1 minute. Okay, Finn's sequence matchmaker. Okay, so See, actually, once you download the files, in Chimera there is an option, because I don't know why it's not working here. In these tools, there is a way to overlap the two proteins. Then we can see what is the match between the actual experimental protein and the predicted one. So that's why I took a known protein for which the structure is known actually. Okay, once we align this one actually, both will align accurately, almost like 99%. So that way we can verify for this particular protein. So that way we can see how well the AlphaFold tree is working in predicting protein structures. What happened? Yeah, I'll show you 1 minute. Once again, I'll show you. Yeah, is your job done? Is your job complete? Yeah. Yes. So for that actually you need to download the protein. Okay, how do you download? You go to the submission website where you submitted, you come here, click on these 3 dots, say download. Okay, it will download in zip format, just say download and it will automatically download wherever you want to download, maybe in download folder. Okay, so in that folder please go there and just unzip the folder. Okay, so once you unzip, you can see so many files in that. There is something called zip files. Okay, there are some zip files. Just load these zip files into Chimera. Yeah, one of the zip file you load into Chimera. Then you are already, the experimental PDB file is already there in Chimera. Then you go to sequences. 1 minute. Go to file. The zip files are there, no? Zip files are there. Okay, so basically you can compare two protein structures actually using this camera. Okay, that way we can compare how well is the prediction. Okay, fine. So another important thing that I wanted to discuss is about the materials explorer actually. Okay, so this is all about the materials project. So materials project is basically intended to design new materials with new properties. So there are so many materials which are there in the literature actually. So using this materials project, we can access already existing data in the literature actually. Then we can manipulate this data using machine learning or whatever actually. You can predict new materials. That is the whole idea. So if you want to access this particular database, the way to go to this particular website is go to Google. In the Google, you just type materials project. Okay, here again you see materials project. Okay, but you need to log in here, log in this particular website with your email. With the Gmail, you may have to log in to the website, that you can access the data. When you go first time, it will ask for login. Just log in to the website, you can log into the website. Okay, and here if you come to the website, you can see start exploring materials. Otherwise, go to this app. Okay, you just come to this app. In the apps, you can see there are lots of databases available actually. One is called Materials Explorer. If you click on this Materials Explorer, you see a periodic table and with lot of properties in the left hand side. Okay, suppose if you want to, these are some general data sets available actually. So if you want to very specifically search for certain information, you want to search materials with certain elements. Suppose if you want to search elements with something like sodium and oxygen, suppose you go here, sodium, just click on the atoms in the periodic table itself, sodium and oxygen, say search. So it will show all the crystalline materials which are available having sodium and oxygen elements. And if you want to very specifically know the corresponding properties, you can see all the properties here actually. And here the columns, you can see what are the columns available. So every column corresponds to different properties. You can select volume, you can select density, you can select the formation energy. Okay, band gap. Okay, work function you can take. Okay. See, you can see all these properties in this particular table actually. Okay. So once you select the elements, whatever you wanted to fetch, you come here actually, come to the export, say confirm export, because you wanted to design new materials with the new properties, right? So come here, say confirm export. It is slow, slightly slow. Whatever is in the literature is available here. Whatever is there in the literature, it is available. Yeah, these are for inorganic database. This is for the inorganic database. If you want to look at some organic database, you may have to look at some Cambridge crystallographic database. Cambridge crystallographic database. You have to look at CCD. CCD, Cambridge crystallographic database. Okay, so once you select the elements, once you select all the properties, whatever you wanted to have here, just go here, say export table, then say confirm export. Okay, so once you select that, automatically all this information will get downloaded as an Excel sheet, again as a CSV file. Okay, go to this CSV file, open this CSV file. Okay, these are the information. These are the crystals, 27 crystals with all these properties. Okay, so now if you want to load this one to your Orange for machine learning kind of things, because you have to train your neural network with these properties. Okay, you can load this Excel sheet into Orange. You can train the neural network. You can try to predict some properties, okay, unknown structure. Okay, so what we'll do is we'll go to Orange. Right? Okay, you go to the file, click on the file. You might have done hands-on, right, on the Orange, right? Okay, so in this, open the Orange, then go to the data here, the first, in that data you just select file, okay? You can see the file here, double click on this, and from here, you go to this browse, and you have to see where it got downloaded actually, this Excel sheet, okay? Save file, save as, downloads, I'll keep it in the table export. Okay, so I'm just keeping this Excel sheet here open. Okay, so when you are loading this data in Orange, you have to say which column is your feature and which column is the target. For a neural network, you have to say which is the input, You can have many information as your input, and you have to associate that particular information. Okay, suppose if you want to manipulate band structure or band gap, okay, first you need to train your neural network with the band gap information. Okay, so how do you keep your band gap as target in the orange? When you do, this is the loading page of the orange. See, okay, see there are information. These are some of the information are categorical, some of them are numeric. Okay, so your band gap is a number. Okay, so it's a numeric information, and this feature, if you click on this feature, there is an arrow here. Keep it as target. Okay, so if you select that as a target, that's the output. Okay, so basically you are going to load your entire data, all the crystals into orange, but all the structural information are your input, and you are associating that structural information with your band gap. Okay, okay, so while loading itself you have to say that, say apply. So if you want to see the distribution, I think okay. So you can also see the data table, whether it is right or wrong. Whatever you loaded is correct or wrong. See, so this is your output, band gap. You kept only one column as your target. That is your band gap. So that is in one color. So all the other rest of the other things are like input. These are the features. Okay. So now you want to associate this one with neural network, right? So from here, give a neural. You can also check the scatter plots actually. You can do a scatter plot and check how is the database. That's what we did in the last class. Visualize. Scatter plot. Okay. Then for scatter plot, you have to associate your data table with the scatter plot. Okay. Click here. So to select it actually. Okay. So since I selected all the data in that table, so here we are going to keep next axis some feature, and here we are going to keep your band gap. So this is going to see the distribution of band gap. So this is one of the features, and this is the band gap that you want to predict. So now what is the next step? You want to associate this one with a neural network, right, for training. How do you do it actually? Neural network. Then you have to do what? Model neural network, evaluate, right? Test and score. You are associating this one the test and code. Okay, so you have to select the parameters for the neural network and you have to do the test and score. So you have to do a cross validation. Okay. What is the trouble actually? Okay, you can do the neural network training actually, okay, from this data. So basically, some data you can select from here actually. Yeah. So yeah, just click here and click on the data table, select only few. Okay, so whatever you selected you can see. If you select only very few, you can see, if you select more you can see in the background more and more features are coming actually. But we need to do the training and test now. We'll stop here actually. They actually, yeah. Okay. So basically we discussed about the AlphaFold, how to predict protein structure, how to see some of the data. 3-dimensional structure, you can, there are so many free packages, like Chimera is one of them actually. Okay, Chimera is one of them, you can visualize a from the AlphaFold you can download that zip files, you can upload in Chimera and check. I got it actually, I'll show you. Okay. Please come. Okay. They're done now already. On their side. Yes, sir. Actually, for reactions, that madam is ready. Reactions, you can do it actually. Yeah. For reactions, you can save everything in that smiles format. But somehow I think this is for the smiles.
its own, right? So some people have already installed Python, right? So if you follow my slides, you can even move to next step, pip install and Jupyter Notebook, till where we have to reach. Please move ahead in these slides, huh? So okay, raise your hands who don't have Python till now. We'll come to those. 1, 2, 3. So yeah, if you help one person, then it will be done. Press click. Yeah. Yes, fine, it's fine. Save. Now click there once it is there. Click on it. Install Python. So let it happen. Yes. Bye. So it is saying, so system administrator, it's saying you need some changes in system, it's fine, it's just a Python. So press Y, yeah. Press Y. Enter Y, yeah, that's all. Yes. Yes. Enter. Okay. Yes. Say yes. Here, yes. 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 Okay, so let it done. So this is done. Who else needs help? Okay. And those who have done, can you also help others? It would really help us to move forward, right? Please help, sir, yes. Have you installed Python? So is पर click कीजिए, download. See, once you have that page, there is a big button, download Python. Click on it. Then it will be downloaded. Click on it. Install it. Standalone. See, this alone. Yeah. Click on it now. Have you installed it? So launch Python. Now say yes. Okay, just follow. Can you help him? Yes. बंद कर दो. Close it. Now go to terminal. So it's done, okay. So if you, but help him with that. Install, click on install. So this is done. This done. Install. So tell them to open those terminal. Okay. If you are going with install. So open a terminal. So PowerShell. See, look at the second initial setup. Open the Windows PowerShell. Search here. Windows PowerShell. PowerShell. Right, Windows PowerShell. Madam, right. So who all needs Python help? Here. Where did you go to download? Click here. Sorry, कोई help कर दीजिए. Modify. It's already there, I think. Now we have to go to PowerShell. Windows PowerShell. Okay, here. So, path, that is important. Is it solved for you? Madam? Okay. Now, right here, Windows PowerShell. So, So I installed this. Is it okay? Now please raise your hand who has been struggling with Python. It's for everybody. Now open Windows PowerShell. Madam, likho, type. Where is it? Open. Yes, be here. Everybody be on this Windows PowerShell. That's called terminal also, okay? Done? Everybody's अब इसके बाद now close this. Okay. Now this is done. So we have to search for Windows PowerShell. Okay, we are here now. So now everybody has opened a terminal which Windows PowerShell. Did we all reach there? Okay, great. So if you follow this next slide now, initial setup, open the Windows PowerShell, right? So just for your information, in Windows we call it Windows PowerShell. In MacBook it is called terminal, meaning if it's a Linux machine operating system, it will be called terminal. Just for your reference I'm telling. Click start, type CMD. So you write CMD there and press enter. Then write Python ---- version. So we have to just do these 3 commands, then we are set. Okay. CMD, enter. No, go here. PowerShell is there already, you don't have to install. Okay? Okay? CMD, then Python. Okay, it shows there is a version. Then you have to do pip install. Typical lab. Tell me if it's coming. Let it come. It's working. This is Mac, na? So syntax is different, sir. I'll tell you now. So this is mine is also. So now. Sir, can I stick it? Why am I coming out of this? Wait. You have a terminal, na? Not this. There must be a terminal here. Where is terminal from this? You don't have a terminal? There has to be a terminal, right? In MacBook by default it comes actually. Where can I search here? Open this. Okay. Okay. So here you have to work on this. So you have Python 3.14 already installed. Okay. So now you have to install Jupyter. This work. This doesn't. Let's see pip 3.14. Okay, like this one. So 2 people got Jupyter here. Did we get anything? ---- version. Okay, so now run that command. Pip install Jupyter. Great. So you are at the right place. Follow my instructions if you want to follow. Did we get Jupyter lab here? Yep. See, read properly. Pip space is there. Please follow those spaces. In computer, spaces has to be followed properly. Ma'am, where are we? So now you write those commands. Okay. So now write that Python space ---- version. After that, pip install. Sir, let it happen. Good. Sir. Slides, open my slides. Click this link. System admin, कौन है वो? हाँ सर, इनका पाइथन कराइए प्लीज. Click on this, download. अरे सर ये दिख रहा है, हाँ. Click on this, ठीक है? So he is going back. Can you make him set up till there then? Thank you so much. You are helping me. So, it's fine. So this is done. No, but you cannot find a version. Okay, flip. Wait. Sorry, Danish. So here this pip is not coming by default. So if I have to know a version in Windows, how will I find? If it's not finding a version. Aib लिखा है आपने sir. See, नहीं LAB. Please type properly. Please don't type wrong. It will not work, right? Let's do it fast. We have to do a lot in 1 hour. It will take 2 minutes. हो गया. This is good. So Jupyter Lab is done. Now last command is, so it will open something new. Okay. So it is open. Hey, why it is asking for not you? Danish, why it is asking for an app to open this? For Jupyter Lab, app to open this. See this. Huh? Sir, okay. You have installed Python, right? So, did you do this pip install? This is the one, okay, which is not working now. Can you move? I want to sit in. What about you guys? Is it working for you? Then this has, so it doesn't have pip looks like. So this doesn't, but Python when we download pip comes automatically. Why it is saying that pip is not there? Dhanish, do you know this? Because he knows Windows, I am Mac person. Python is installed, but when we are doing this pip install, pip is not recognized. It means pip is not there. Huh? But how come? Python installs that, na? So how can we check here? Like in MacBook, we can easily check, right? See, na, it's there. Then how can I figure out what all got downloaded? Mac, it's easy, na? We will see. Next. Pip is not there. How to wait? That is also. What about you? I think these are old Windows, so maybe then I will suggest you sit. Sir, these 3 computers have old Windows, looks like. You downloaded pip. We can. But can you Google this? What is that? Just these 3, huh? See, otherwise call me. Working? Is it done? Sir, these desktops are old, huh? Because 3 has the same issue. These 3. Little old. Because others it's working fine. It will open a new thing. Well, is still good. Good. This is where we want, sir. No, it's not. You have installed this. It was not required, but fine. But did you do that pip install Jupyter Lab? Did you do that command? No, you didn't. Otherwise, why would it not? That is done, but then why it is not finding Jupyter Lab? Oh, you are writing the wrong thing. How to copy this? Command Control C works, right? So if you have my slides, if you go to next steps, maybe it will help you. It is already there, it is saying. Okay, I have to check this. It is there, looks like, but why it is not working? Huh. This I don't know why. It installed, but it's not. So this is Windows. The problem is I was in Mac, but you know, can you see this? Maybe it's not set in the path or what? Can you check this? Who all? Is there any issue? Everybody is on Jupyter notebook now? Huh. So it is installing things, then error. Is there any other desktop you can work on? This desktop has an issue. How? Path, I think. Either move to next step. Okay, since Max, this will help those who are not done, but I'll move to next step so that we have at least some time. Oh, 110 already. Okay, so everybody has done this Jupyter Lab, those who it worked for. You have opened a new window, right, if you see. So now, this is all done. So you have a window like this, right? So now if you see, now this is, what is it? Please hear me out for a minute. Why we installed Python? Because the code is written in Python. Jupyter Lab is an environment tool where you can import any Python file and you can do the coding. It's a very nice thing. You can write comments, you can do coding, many things. So I'll show you. So now you need to upload a file here. Like you have to run something, right? A code which I have written. So you can download the file from here. Click on this link, first link, Download both of them. So this is a file which is a Python file which has a code. This is the input data set, CERN data set. I also give you two links which has many data sets from CERN, okay, because many of you wanted different CERN data sets. These two links have a lot of data sets, don't worry about that. For the time being, download this. This is a Python file and this is a data set which we are using to run that Python file, okay. So click on these two links and download them. Please click on those links. Are you able to click? You got the files? Download it, huh? Okay. Not here. You have to go to, you have slides now. In the slides, click on this link and download. Otherwise, how will you download, right? You have to go to slides, not on terminal. Everybody is clear? I'll come, but let me show one more slide, then I'm coming to you. Now, how you will open the Python file? Open this Jupyter Lab is there. Click on this button. This is arrow button. Okay. There it will show you, open a window. So go to downloads and get that file, Jupyter file. It's not visible, right? Here. Now go here, arrow, right? So this is the entire code and the everything. Go up, scroll up, read this. So it has everything. You wanted a code which will run and get you plots, it has everything. It's a very straightforward thing. I'll explain to you the code then. Sir, यहाँ नहीं, अब आप जाइए इधर. Jupyter Lab is there. You open it now. Where is Jupyter Lab? Open na Jupyter Lab. It didn't open. So this you download, okay? This you download. These are the files you have downloaded, okay? But where is our this one? It didn't open. Did you not run this command? Okay, see this. What happened there? What about you? See. Some has different settings, that's why. Sir, is it open? So where are you? This is here, na? This is, oh, you didn't do anything. Sir, then you would have called us, na? It's been a while now. You didn't download Python till now. What were you doing there? Half an hour. Is it installed here? It is installed. Where is your right shell window? SHELL. It is here already. Right, why? No, wait. Did it not open anything? But you guys are telling it worked for you. So you had to do just this. Okay? It works now. Okay? So now what happened here? This guy will see same error he is also getting. See, Jupyter Lab is not opening in few places. Is Jupyter Lab opened? Whatever you want. What is the time now? Many people have installed at least, right? Jupyter Lab has come up right there. It came right. So if you see, That is what. But if you see, if you follow these instructions, it's there in slides. It will work out for you because some desktops has some issues also, I think. So if you have opened a file, right? So now it looks like this, right? In Jupyter Notebook, it has opened and it's telling you. So the exercise we are doing is hunting the Higgs boson with a neural network. So real LHC data we are using on a Higgs to ZZ to 4L. Okay. So now, see, Jupyter Lab is a very nice tool in the sense you can see just comments. It's written very nicely. Everything is written for you. If you read, you will follow. That's how we did it. Then there is a shell also, meaning where we are writing the code. So if you see, like this is the first command, right? So how do you run any shell? Go to the end and enter. Yes, control enter na in Windows. Shift enter. If you put a shift enter here, it will run that shell. Right now you are already seeing the plots, right? It's all there. But what, because there is a data file, there is a .csv file which is important. What if you want to change the data file? So you have to run thing again, right? So it's like interactive. You don't have to run like a command, you enter, shift enter, the code will run right there in front of you and you can see a plot. Is it making sense? If not, sir, ये मेरा laptop लग जाएगा? Can you put my laptop here? हाँ? Just मेरा ये बात और इसका अच्छा है तुम्हारा वो है ना सिंपल मेरा मैक नहीं लगा अपना लगाओ we'll show them how to run open that file we'll show them is it possible to connect MacBook Type-C is there we'll use his laptop use his Windows this will work here this doesn't have a good resolution your screen actually start मेरे दे हाँ So then I will explain to you this now. See, this is how the notebook is right now. So this has the, you can see this is all type I have typed. It's like a text file. You can type also, you can write a code also. See, in case you want to see how an empty file looks like, okay. So if I click on this plus, I can create a new file, right? So new file will look like this, just commands. So you can write import the code, okay. So the way I have written is, I have written some comments also. So this is all comments like we are looking for a Higgs study. The first step is to do something. So how do you think? This is a shell, okay? How do you run it? In MacBook, because some people have Mac, in every this box, okay, this is a command. You do command, enter, it will run. In Windows, shift, enter. Go to this place, wherever some people have opened, right? So if you do shift, enter, it will run, meaning it is running that part of a code for you. Okay? Then, so it has, first it has to import few things. So now it is, see, how do we know it's running? There is this star will come there in the left. For me, it's already ran, right? Otherwise, the star will come, which will tell it is still running. The code is still running. Okay? And at the end, it shows the green box, imports done. So if you click now, it will take you some time because it will import few things. For those it has opened, try to do that. At the end of this, here, put a control enter, working? So shift for Windows, for MacBook, sir, sorry. So now this is good. Did you upload a file? So download, where is that Python file? Here. Okay, so this is there. So now, so this way you can run the commands and this file is entire, like you wanted a code with the description, We did it for you, okay? So it has, what is it doing? Meaning if you want to understand. So this file is doing what I talked to you about Higgs, right? So we are discovering Higgs using a machine learning, which is deep neural network. Even a training is happening in the code. I'll walk you those steps now. I don't have to go in details because you don't know that enough, but if you have to tell students, you can tell them. And the plots also appears there itself. So first thing here is, you have to load the data. See this file, CSV file. I asked you to download the second file, right? That is data. Data is in CSV format. CSV everybody know, right? Excel sheet. What are the parameters it has? It's written here. It has a charge of a particle, energy of a particle, momentum of a particle. Very basic things. Then, if you see here, it is like printing. What are the particles? Now you want to plot some things, okay? Higgs peak, the actual discovery plot. You can see here, when you run in the same, this tool itself, you can even make plots, which is the nice thing about this tool, okay? So if you later on get some time, this Jupyter notebook is very nice. You just need to import a Python file which you have written and a data. So now you can see here, this is a signal. The signal was supposed to be at 25, the mass value we knew, and these are background. On this data we have trained. We have done a deep neural network training, which I will show you below. So these are, so if you know little bit about machine learning, training requires different parameters, right? So we have different parameters, masses, momentum, Who is speaking? Can you raise who is speaking? Bolo. You have to download from there, na? You have to change the path. So, okay, because this has my path. See, if you don't enter, it will work. But if you have to change something, see here you have to change a path, right? Because when you load, here you see, it is my path, user Bhavna Gomba download. So you need to know where you have downloaded the file, right? And you mention that path here. Then it will work for the file which you have on your desktop. Clear? So then I will show you a, so network is trained. When we say training of the network, here is the plot. We look at the loss function as a function of epoch. I don't know how much this, right? But we have all the plots. You see how the training is working. Then the main thing is this ROC plot. So this is the main plot which comes from the machine learning. False positive rate versus true positive rate. Meaning what you are telling is a signal, is actually a signal or not. Those plots we got signal efficiency plots. Then this is also very important thing which you get from machine learning is the parameters which you have trained. Which one is the most important? Here you can say M12, it's the mass. So it shows about the importance of each parameter. Because when you train a model, you are giving a lot of parameters in a model, right? So which parameter is most important is also one of the output of this machine learning. So we have that plot also. And these are the final plots. This is the mass and this is the network score. Okay. So the main idea was for you guys is there has to be something which is easy to run and students can do. So I think this is doing that job, right? And if you have to understand this, there is a lot of text I have written, right? So you can even read that. If you have to explain to some, even students can read themselves, right? It is very self-sufficient. The only thing you need is Python and install this Jupyter Lab with those 3 commands. That's all you need, and then everything runs very nicely. And if you want to change data set, there is a link in the slide, which has a lot of data sets for Sun, right? And the data set is in the format of CSV. Very simple Excel sheet. Now I can come and answer your questions in case you have, like, if you're not able to change a path or you want to run yourself, or what is it? This is all I wanted to show from my side. But is there an overall common question? Then ask me. I hope this is what you wanted from us. Is this solving the purpose which you guys wanted, right? like a proper clear example which can run like a black box, right? So here you go. Okay, so now who has issues? I'll come. Huh. I asked you when I was teaching theory, wo madam boring. She told we don't care. We need something. So of course, students need, see, how can you do machine learning, tell me, without knowing C++, without knowing Python? Even if you're doing something in chemistry, you must be using some programming language, right? So that's the command student has. You cannot do machine learning without knowing a programming language. That is very clear. Be it C++, be it Python. Python is a very powerful language which is used everywhere. That's why I will suggest all of you that have a course in your degree colleges of Python. That helps a lot. I mean, and these are very basic Python. And you know, these days you don't even need a teacher. Chat GPT, Python tutorial, you can read yourself and learn in like a week. I mean, so how now more? What more can I tell here? I mean, think, right, from this perspective. You must be standing on this side also many times. You cannot, not this, you cannot do machine learning without knowing a single programming language. You have to tell this to your administration, to your senior people. I mean, this is the base. Okay, even to follow anything, you need to know little bit of programming language, right? I mean, that has to be made clear if people are not clear. I don't know how was the previous faculty was teaching you, not any programming language. Then how did you do machine learning? What tool is based on a programming language? See, every field will use a different tool. We don't use, in physics, nobody uses orange. Chemistry might be using that. So how to ride a bike is I have shown you. This will help you. Correct? So how to run it now you know. That is what, so, but this will help you, I mean. Okay, I don't know, then this is like even like a level where we can go. Without this, how can, So then how will you do machine learning? One has to learn at least something. Send me a link. I gave you my number. I will write it very clearly. In physics, you cannot do machine learning without knowing a basic programming language. It is impossible. I mean, I don't know how that, I'll ask you that faculty, how he is doing machine learning in air? I don't know. There has to be a programming language introduced in a degree college if they want the students to have a feel of machine learning. That's clear cut. I mean, you cannot do without that. It's impossible, I mean. So how you are doing getting orange tool, I still don't follow. So here you have out, look at the last part. because we want people to maybe learn. Acha, here you are pressing buttons, huh? See, gradient boost, it's a machine learning thing. Somebody has written a code for that, okay? Here you will enter a button at the end of a code. There you are entering a button in the... Not good. But maybe chemistry work, because see, think of people who are chemistry. They don't know machine learning, I think, then. If they are learning like this, they don't know, according to me. I'll talk to you in that faculty. He may be unhappy when I make that statement, but physics people, if you see, physics will always go with mathematics. If you know mathematics, you can do a lot of programming, right? I know. This is like pura button daba ho gaya. 5 here, madam. Shift enter, madam. So there is a issue, so you are not writing. Users download table. No, but is this the one you have used? No, I didn't download. My file name was 6/2012. So you have to use the correct file. That is why it's not able to read. Madam, this one. This is correct, sir. Oh, so it means, see, when this error, you have to run each command. If you didn't run this one, see, this means you didn't run this. You have to run from the start. Because now you are changing things, so it doesn't know the previous thing. Madam, आपकी satisfaction के लिए मैंने कर दिया ये. आप मुझे नहीं. Because you told me whatever I taught is useless, so I got very mad at that part. I was like, I have to do something. Kuch bhi, I mean anything machine learning. I don't know why you guys don't realize it yourself. See, chemistry, because maybe those people also don't know this then, I feel. Because there is, chemistry people don't know the babe. Not you, even the people, they are not going into expertise of machine learning, they are running tools like that. But physics cannot happen without, in physics, I don't know if there is a software which can do this. I would suggest give it to students, they will appreciate you. I can bet you this. I mean, if they can get a Higgs discovery plot, they will really appreciate it. So you have to run from the first. Did you run? I'm coming back. Thank you so much. So it's not working at this stage, huh? Because it's saying invalid sequence happened. Okay. So this may be an issue of a Windows version. So this is it's basically like a, you know, LaTeX, right? Little bit. So it is printing that ELL. So it's the syntax might be different in this one versus the one which we have. So this is the issue coming. See, it's taking it as a, it's blue. So it's not taking it as a. So let's remove this if I say. So this will just change the label, okay? This is the error. Let's try to run it. Okay. That was just a, see, now it is not coming as a label. Write the proper. That is a nice way to write a label. That's all. It's just a text. Okay, now if you do next step, it will go in this one. So it is just showing you the signal and the background labeling. One thing we did nicely is we wrote everything. So even if you read later, you will follow something. No, this is not a command. This is just a text. This is a command. Yes. Then, okay, now next step. So that everything will work. Most welcome. So you guys are missing lunch, huh? Even I'm missing lunch. You had lunch. So you will have between 1:45 to 2, I think. Next session starts at 2, right? Good luck. I think today is the last day for all of you. Yeah. Worked for you? Work. I'll check. What is the issue here? I don't know. I'm starting from the beginning. No, they are pressing buttons. वो chemistry में बड़ा अच्छा tool है. Press button, it will create a model. Press button, they don't need to know, see even this code. Press button, random forest is getting implemented. They don't care about this random forest, but button दबा के हो रहा है. Here it's like at least you have to, there is an error here. Do we have to do this? The problem is these desktops are some old desktops. No, most of them. That link is there. Same thing. Yeah. That is why I gave you lot of time. Link is there.
Sorry, you guys are too busy today. Actually, we are having almost, one extra session, so we have to accumulate the time according to that. That's why. So next session will be taken by the Dr. Prashant Kumar sir. So let me give the brief introduction about sir. Sir is currently serving as a scientist D in the seismology division. His specialization is in seismology with key research interest in seismic anisotropy and the application of machine learning techniques in seismology. Through his research, he contributes to improving our understanding of the Earth's internal structure and seismic processes. His work integrates advanced computational methods with geophysical studies, making significant contributions to modern seismological research. We are delighted to have him with us today to share his knowledge and insights. Thank you so much, sir. Over to you.
Good afternoon, everyone. I am Dr. Pawan Kumar Nigala from CSR Engineering, working as a scientist in seismology. So especially today's topic is earth sciences, and that too related to earthquakes. Earthquakes mainly deals with the seismology. So seismology the studies, science which is studies about the earthquakes. So how to apply the AML? Last 5 days we are listening about the AML tools. So in this today's section, I am going to introduce how to introduce AML into earthquake sciences. So earthquake is always a big challenge. So here we given the prediction, but exactly prediction is not possible. But here we can give the at least which are the active regions, so that we can alert the people and we can go for the high resistant buildings. So in that case, how to use the AML, those sections. But before going to apply AML, in order to any, first of all, what you have to understand? Data. So without understanding of the data, we cannot apply the AML. For that reason, first I will give the basic of the earthquakes, how the earthquakes happens, and how the earthquakes data looks like. Where you will get the earthquake data, whether this data is freely available or not. Once it is freely available, how to you can go for the AML. So for that I will start from the basics. And then we will go for the demonstration using the orange. Orange is the one data mining tool where you can apply the AML tools by simply applying the GUI input. Whereas in Python, what you have to do? You have to write a big scripts, big script. Whereas in Orange, we can reduce that scripting language, and with simple connecting tools, we can apply the AML. So first we'll go for the basics of the earthquakes. Before going to that, first of all, I want to introduce about my institute. It is CSR India, National Geophysical Research Institute. It is one of the premier research institute in the India, which will deal with the earth sciences. So your earth sciences means what we will do, geodynamics means we can go up to thousands of kilometers. So in the earthquake data set, we can go for up to 1,000 kilometers and we can give the earth structures and earthquake hazards. And we have given the so many like places like so that even though 8 and above magnitude earthquakes also happens. Hydrocarbons like petroleum, natural. Okay. Means there are the potential groundwater regions in the entire India. So our industries are mainly deals with the oil and gas minerals. Oil is YBC, gas is that from gas is coal is figuring products are there, minerals, AMD, atomic mineral detector. We have transport of India. So they will get the data and they will analyze and they will get the proper information about the domain. Strategy means nuclear powers. Yes. Where you will start the nuclear power? If you want to build a nuclear power, first what you have to do, whether that area is under seismic zone or not. Seismic zone means where frequently earthquakes are happening. If the even 200 magnitude earthquake also there, they won't go to build the nuclear power because if small earthquake also happen, small damage causes the big hazards. That's why nuclear power corporations, they have to come to us and they will get the what is the proper less seismic zone shelter and they will take such sites and they will build the nuclear power plants. And societally, we give the groundwater analysis. Where are the potential groundwater zones are there? Those will identify like BB projects and we will give the also we will do the earthquake hazard assessment very important and basic target is the how Indian plate is moving. Those things we will discuss now. And because of some key features of our India, we have the first gravity map and first these are the seismic earthquake. They know the potential gas there, oil those information and it is important. This is the seismic donation map. So now at the end you are going to be the how seismic donation map can happen. How you can deal with the area. That things also you can do this. Yes. So that is our issue. Now we go to the actual seismic. So actually it is divided into three parts mainly. Crust, matter and the crust and upper mantle is one of the lithosphere and below that there is a low viscous material is there that is the fluid type that is called the atmosphere. And within that core what happens? Lot of temperature and pressure is there. So between the crust and core there are high temperature pressures and fluid is there. Due to this high temperature pressures what happens? This fluid will be boiled and they will form as a volcanoes. Due to this volcanoes, what happens? So this is the lithosphere, and this one lithosphere is not continuous. At the oceans, what happened? Oceans, it is clean. At the continents, at mountain regions, it is clean. Now, if the magma comes up, which area will be broken? Ocean. So that lithosphere will broken and they form as two blocks. Those blocks are known as the plates. And this is one of the plate tectonic theory. So when two plates are formed, what happens? They are floating under atmosphere. So what happens? Some of them will be collide. They are known as the convergent modes. Some of them move away from each other. They are known as the divergent. Some of them what happens? They will move parallel to each other. They are known as the transform. Why I am saying this? This is very connection to the our psychology. That's why I am telling all of this. Before Pakistan, we don't have these many components. We have only one single component for the Pandya. But due to the side temperature and pressure component, slowly this Pandya is broken into two blocks. One is called the Ganesha, one is called the Gurma. If you observe, our image is under Gurma. And our magnetic plate is the once again, this Gurma started.
So once again, what happened? This Gondwana started broken by because this is a continuous process. This core is having high temperature pressures and this continuous process. And once again, Gondwana is broken into these many continents. After the India is our one of the major plate. But what is our neighboring plate? Our neighboring plate is the Laurasia that later became as a Eurasia. So this India plate started moving with the initially it is moving with the velocity of 20 centimeters per year. So 50 million years ago, we don't have Himalayas. But what happened when the Gondwana broken? Slowly, what happened? This Indian plate start moving, and it started moving and collided with our neighboring plate called the Eurasia. So in between, what is there? Ocean is there. But due to this collision, what happened? That Indian plate is subducted under Eurasian plate, and whatever the material is there, they came up and they formed as a mountains. What are those mountains? Himalayas. And still Himalaya site are increasing. What is the reason? So initially it is 20 centimeters per year, but after collating, what happened? Obviously, speed will be reduced, and now the speed of the Indian plate is 4 centimeters per year, and with the 4 centimeters per year, still it is collating with the Eurasian plate, and height of the Himalayas are increasing. So total there are 17 plates are there like this. Out of 17, 7 are major plates, and there are small plates also there. Remaining 10 are small plates. But our India is one of the bigger plate, and it is colliding with the Eurasian plate. Okay, there are plates existing. But how scientists came to know that these plate tectonics are true? So we are saying that their plates are existing. But whether they are true or false, scientists has to answer. For that, what they have done, they choose a seismology. Seismology is the subject which deals with the earthquakes. They choose a seismology as one tool, and they started installing the seismometers. What is the seismometers? Seismometer is the instrument which will record the earthquakes. So they install the seismometers worldwide. Worldwide they installed, and they collected the earthquake data set. They plotted on the global map. This is the global map. Now tell me, all these are the earthquakes. All these are the earthquakes. And this is your major plate boundaries. Now tell me what you observe. Pattern means at the boundaries, earthquakes are occurring. What is the reason? Simple reason. At the boundary, what happened? Always collision will take place. And famous Hooke's law. The beginning of seismology starts with the Hooke's law. Hooke's law says that within the elastic limit, stress is always proportional to the strain. So due to this collision, what happened? These rocks also, earth contains so many rocks. Rocks also having the so much of elastic parameters. So once they are reaching the elastic limit, what happened? They have to release the energy. And due to this collision, what happened? Stress continuously supplies. And due to this reason, what is happening in the Himalaya? Why you are getting the earthquakes in Himalaya more compared to our South India? Because Himalayas are formed due to the collision of our Indian plate with the Eurasian plate, and still it is colliding. That is the reason why you are getting most of the earthquakes at the Himalayas. So now you have to study earthquakes very intensively, and you have to find where are the potential zones, high risk zones are there. Those zones you have to identify through the AML. And that is the reason in Himalayas there is a chance of getting 8 and above magnitude. Last 8 magnitude is happened in the 1908 Kinnar earthquake. Kinnar means Himachal. In Himachal 1908, one big earthquake is happened whose magnitude is 8. After that, Uttarakhand region we didn't get the big earthquake. Why? Because due to this collision, stress is daily accumulating. But up to when it will accumulate? Up to its elastic limit. Once it reaches the elastic limit, it has to reach the energy. That energy may be 8 and above. So there is a big chance of getting 8 magnitude earthquake in the Himalayas. So this is how scientists came to know that the plate tectonics are exist by using the earthquakes. Okay, finally, now what is an earthquake? The basic definition of earthquake is the sudden release of energy. So a simple example is you take this simple pendulum, spring you take, and you go on at the mass. What happened? Spring will be stretches. After reaching the elastic limit, what happened? It won't stretch. Suddenly it will be break. So that is the word is important. Sudden release of energy. That is why still prediction of earthquake is not possible, because we don't know when it is suddenly happens, because it is continuously accumulating the stress. But when this stress will release, that we cannot know, because it depends on an elastic limit. And these are the important parameters. So this is called focus. Yes, that thing we have to now. Previously we don't have this much data set. Okay, now slowly we are getting. Last 60 years, out, not 60 years, last 30 years, instrumentation is increased compared to previously. Now instruments increased, so data is also increased. For AML, what I told, for AML, you require a huge data set. You require a huge earthquake data set. Now slowly we are acquiring the huge earthquake data. Now it's the time. You can apply whatever the algorithms you know, just try to apply and take one big earthquake. Okay. And for that earthquake, before 10 years, at least 10 years, you take what are the anomalies are happened. To get this 8 magnitude earthquake, what are the anomalies are happened? That you have to predict using the AML. So same anomalies you are getting now also. Means you can expect there is also a 8 magnitude earthquake in future. But exact time and date in present scenario it is not possible. And this is called the focus. Focus is the point where exactly earthquake is happened. And this is called the epicenter. Epicenter is nothing but the location. So when an earthquake comes, immediately you tell earthquake is happened in the Mulgu. Recently, one earthquake is happened, 2024. In Mulgu, there is a big earthquake is happened whose magnitude is 5. So that is called the epicenter. Epicenter means it is the location of earthquake. Focus means where exactly earthquake is happened. And what is epicentral distance? Epicentral distance means your seismometer, means your recording station to epicenter, whatever the distance is there, that is called the epicentral distance. So these are the some key points regarding the earthquake. First one is the focus, next is the epicenter, and focal depth means at what depth. So why depth is important? Because take 6 magnitude earthquake, take same 6 magnitude earthquake. One 6 magnitude earthquake happened at the 10 kilometer depth. One 6 magnitude earthquake happened at the 50 kilometer depth. Now, which earthquake caused the more damage? 10 kilometer, obviously, because to travel from 50 kilometer to surface, it will take a lot of time and energy will be dissipated. Same 6, but what happened? Your depth is less. That's why your damage is more. So for Mulgu, what happened? Mulgu earthquake magnitude is 5 only, but it is happened within 10 kilometers depth. That's why those vibrations went up to Vizag also. Here up to Hyderabad also, people are received vibrations. The reason is 10 kilometers only. Even though it is 5 magnitude, depth is less. So depth also plays crucial role in earthquake hazards. And generally earthquake intensity is measured in the 1 to 12. Okay. And this is the basic for the seismology, that is Uppsala. Already I mentioned, within the elastic limit, stress is directly proportional to strain, but once it reaches the elastic limit, it won't gain the elasticity and it has to break and it will release a lot of energy. Yes, that next slide I have. Everything I will show. How to calculate the location, how to calculate your magnitude, Richter scale magnitude, everything I will show. So that you will get the what exactly earthquake data set. Now, after this talk, what happened? We'll get the earthquake data set from open source. But if I didn't explain all these things, if you see that Excel form, you didn't understand what are the format, what is magnitude, what is latitude, longitude. That's why. Now, what is the main reason for getting the earthquakes? So, I already told crust. Earth is having crust, mantle, core, and this crust and mantle is called the lithosphere. In lithosphere, what happened? You have the lot of rocks will be there. What is the big feature of rock? Rocks will have the elastic prop. Rocks will have the elastic properties. So every rock will have the elastic properties, shear modulus, angle modulus, bulk modulus, like that. Suppose if you are rock, if you apply the stress, what happened? It will experience the bulk modulus. So it will, if you apply the shear, it will apply the shear modulus. So every rock will have the elastic properties. Once it is the elastic properties means it will have compulsory elastic limit. This is due to this lithosphere, what happened? Continuous stress apply on the rocks. Due to this stress, what happened? Rocks slowly deform. Deform means strain. According to Usla, whatever the stress you will give, that much strain will be there. Stress, strain, stress, strain. But after reaching the rock elastic limit, what happens? It won't deform. It has to release the energy. So that is why here I shown the, so this is the breaking point. Why this breaking point happened? Because it is reached a elastic limit. Now, once it is a breaking point means what happened? This block will be becomes two blocks. Single block of rock will become the two blocks. Why? It is broken. And this is called the faulting. This is called fault. So yes, there is strain meter. Some instruments are available, but not that up to level, because these rocks are within 20 kilometers, 30 kilometers of depth. So by using strain meter, what maximum 1 kilometer, 2 kilometer you can achieve. But earthquake generally happens after 10 kilometers, 10, 20, 30. Some earthquakes will happen up to 400 kilometers. So that is the reason we still lagging behind the prediction of earthquakes and these stress. Okay. So when these blocks, single block will become two blocks, what happened? One block is called the footwall, one block is called the hanging wall. Footwall and hanging wall. And this hanging wall, what happened? This, if the hanging wall going down, why it will going down? Due to gravity. If the hanging wall going down, it is called the normal fault. So this is the case. So hanging wall is going down. And if the hanging wall going up means against gravity, that is called the thrust fault. This type of faults you will observe in the Himalayas. Why? Our Indian plate is subducting under the Eurasian plate, and what happened? What are the structures are there? They came up. That's why most of the thrust faults you can observe in the Himalayas. And finally, another one is the strike slip fault. So in strike slip fault, what happens? It won't go up and down. Simply what happened? It will go side by side. So now tell me, in which faulting most damage will occur? Thrust means, suppose, yes, strike slip. See, in strike slip, what happened? Suddenly it happened, na? So, yes, splitting it will happen like this. But in thrust or normal faulting, what happened? Only it will go down or up. So, but here, that I will show that cartoon. So, see, this is the strike slip part. Before strike slip, what happened? All the trees are aligned. But after earthquake, after this strike slip fault, what happened? The trees are fall down. So mostly strike slip will cause the most of the damage. Okay, up to this is the just introduction about the earthquakes. But how to visualize the earthquakes? In order to apply the AML, first you have to see the pattern, how earthquake pattern looks like. For that, first you have to understand the earthquakes. Earthquakes behaves as a waves. Why? Because when earthquake happens, it creating the disturbance in the earth medium. So whenever there is a disturbance in the medium, it is called the wave. So earthquake also behaves as a waves, and they travels from wherever they start and they will receive to the surface. So how earthquakes looks like? So when an earthquake happened, what happened? Initially it is happened at, suppose, let us say some 10 kilometers of depth. Then what happened? First, the waves start from the focus and they will reach the surface. So the waves which travels within the body, they are known as the body waves. These are very, very important while applying the AML. And after reaching, what happened? They will travel on the surface. That's why they are known as the surface waves. So what earthquake comprise? Earthquake comprise two waves. One is body waves, one is the surface. So finally, this is your earthquake. So how to observe means, so this is called the noise, means initially there is no signal. But when an earthquake starts, what happened? Slowly there is a frequency change. And this block, what are these two blocks are there now? These are the body waves, because body waves will have the less frequencies, whereas this block is the surface waves. Why they have high frequencies? Because they travel on the surface. Whereas body waves, they travels within the body, so lot of energy will be attenuated. And within the body waves also, the wave which, this is a very crucial, very basic for the seismology, because depending on your P and S only, you can locate the earthquake. If you wrongly detect the P and S, your earthquake location is wrong, means you are giving the wrong information. So we have to very careful while picking the P arrival and S arrival. So here this is a textbook example. That's why you are clearly identifying where is P, where is S. But in practical, it won't be like that. In practical, what happens? You have a lot of noise will be there. So there you have to apply some filters. Just go and apply the filters and find out where exactly P arrival. So the wave which I was first called the P wave or primary wave. And after this, what happened? Slowly frequency increase. That wave is known as the S wave or shear wave, or also known as secondary wave. P wave, primary wave, secondary wave, also known as the shear wave. And after these shear waves, this is the high frequency content will become, those are the surface waves. So our aim is, once you have the earthquake data set with you, what you have to do first? First you have to check whether there is earthquake present or not. If earthquake present, where is the P arrival? Where is the S arrival? I will tell why these two are important in the next slides. Definitely, definitely, because once it is originated, it has to reach the receiver. So once it reaches, but depending on depth, what happened? Some of the waves may travel, some of the waves may not travel, but mostly the entire waveform will be, you will observe. This pattern is observed. So now what you have to train your AML? This pattern you have to train. Once these earthquakes like this earthquake you gather from the open source and you train the AML, so that what happens, if I give raw data set, it will automatically detect the earthquake. So that what happens, your physical work will become, because to detect the earthquake and to find out the P and S, for us, for 1 month data, it will take at least 1.5 months. But at the same time, if you apply the AML, within few hours, you will get the entire earthquake information, whether it is earthquake or not. First, if it is earthquake, what you have to do? Where is the P arrival? Where is the S arrival? So that is why AML is important in the seismology. There it will reduce a lot of manual work, so that you can give immediately earthquake catalog. Yeah, this is how waves behaves like. These P waves behaves like a long-term waves. These are nothing but acoustic waves. Okay. Acoustic means we will have compressions and rarefaction. So what happens if any building is there? If a first P wave arrives, what happened to that building? Just it will vibrate like this, but there will be no damage. But if you come to S wave, what happened? S wave particle motion is perpendicular to the wave direction. So you will get up and down like this, so that there is chance of collapse of building. But if you come to surface waves, already surface waves have high frequencies and their motion also very complicated. So that's why more damage occurs due to the surface waves. Compared to S waves, surface waves are more dangerous. So this is how P waves are propagating. This is how S waves. But if you see the, once again in surface wave, there are two types. One is called, the first portion is called low, and second portion is known as the rally. See the motion, how complicated it is. And similarly for low waves. Yeah, finally, not only this P and S, depending on the depth. If the depth increases, what happens? Span, wave span also increases, and they will have different types of phases. This is not that much important for you. And finally, this is the last 60 years, our seismicity of India. Now, from this, what you observe, where most of the earthquakes are occurring? Himalayas, and here Sumatra and Andaman, and we have very big earthquake is happened in 2004, tsunami. 2004 Sumatra earthquake is happened. That given lot of damage. Okay. From this, what happened? Wherever the boundaries are there, most of the earthquakes will occur at the boundaries. And depending on the seismicity, our Earth Science Department, they have developed the seismic zone map. This is a seismic zonation map of India. So from here, our Godavari, this Godavari Rift, and this Vijayawada, this region, there comes under zone 3. And this is the zone 2. Zone 2 means you will expect up to 4 magnitude. Zone 3 means 5 to 6. And similarly, zone 4 means this area, means Himalayas. You will expect up to 6 to 7. And finally, zone 5 means these areas, red areas. You can expect up to 8 also. So depending on our seismicity, so now in this example, when you do the demo, you will clearly observe worldwide how the clusters are happened depending on the magnitudes. That will practice in the orange, so that you will clearly understood how this. So now recent that Mulgu earthquake is happened now. So that is happened near Godavari. Exactly one earthquake is happened in Bhadrachalam also. So why? Because this Godavari graben comes under zone 3. Yes, exactly, sir. So how to record the earthquakes? Now you see how the earthquakes propagate and what are the important parameters. Now, how to record the earthquakes? To record the earthquakes, what we require? We require some instruments. Those are nothing but one is the seismometer. Seismometer is the instrument which will record the earthquake, and one more is the data logger. Means whatever the seismometer will record, they will give the analog signal, but we need the digital data. For that, we need the recorders. So generally, the seismic signals will have the amplitudes from 1 nanometers to 1 meter, and the frequencies changes from 1 millihertz to 1 kilohertz. And these are the this is the first seismometer. It is not seismometer exactly, but this is how initially Chinese people used to find how the earthquake is happened. That time we don't have this much electronics to record the earthquake. Then what they will do? They have the 8 dragons, and near bottom we have the 8 frogs. All the frogs will open the mouth. Okay. On the 8 dragons, they keep 8 balls. When an earthquake comes, what happens? One of the ball fall from the dragon and reaches the frog. So then they decide that, oh, maybe this earthquake is happened in this direction, like that. But there is no quantitative way. When still 1960s, what happened 1960s? In the 20th century, what happened? These electromagnetics came into picture, galvanometers came into picture, and this is the first Wood-Anderson seismogram. And still this is used for the calculate in the Richter scale. Whatever the modern machine you use, but you have to compulsory simulate to the Wood-Anderson. Why? Because when Richter developed the magnitude scale, first he uses the Wood-Anderson seismometer. Still, till today, we take Wood-Anderson seismometer as the reference for magnitude scale. So olden days, how they will record means we have the drums. In drums, we will have the photograph paper. From the photograph paper, what happened? Here we have the galvanometers. From the galvanometers, see, these are the galvanometers. Okay. And from this drum, what happened? Continuously light falls on the galvanometer. From galvanometer to once again they will passes on the photograph paper. Once you develop the photograph paper, you will get the clear earthquake signals. This is called analog seismograms. But now what happened? Everything is digital. So entire data we are getting in the digital format. But olden days we used only the analog seismograms. So already I defined seismometer. What is seismometer? So this is simple mechanical seismograph. What happened? Initially, due to movement of inertia, you have to keep the mass as the steady position. But when an earthquake comes, what happens? Spring will be moves and it will displacement, it will reach. And this is the electromagnetic, that is simple mechanical. What is electromagnetic? Is simple. They will take the one magnet, for that magnet they will give the copper wire. So according to Maxwell equations, what happened? Curl of magnetic field gives the electric field, curl of electric field gives the magnetic field. So initially magnet is in the steady position, means there is no earthquake. But if an earthquake comes, what happens? This magnet will vibrate. Magnet vibrate means it will generate the electric field. To measure that electric field, we will use the galvanometers, that potential difference. So like that, we will, initial days, we use the electromagnet as the one key feature for the record the earthquakes. Then what is seismogram? Seismometer is the instrument which will record the earthquake. But what is seismogram? Seismogram means it is a graphical representation of your earthquake. Means on x-axis will have the time series, on y-axis you will have the all the amplitudes. We will see now how it will look like. So this is how, this is called the complete seismogram. Now any doubt why there are three components? Yes, P and S. So P is the one having the only vertical. They will have only vertical motion. So vertical motion will be clearly visible in the this one, up and down motion. So this is your clear P arrival. But whereas S waves are transverse waves. So transverse waves means they will have perpendicular. That's why you have two horizontal components. One is the north-south, one is the east-west. So this is north-south component, this is east-west. In one component, what happened? You clearly visible the S wave. And these are the remaining surface waves. So like that, if you want to analyze any earthquake, we need compulsory three components: vertical, north-south, and east-west. And y-axis we have amplitude, sir. That means displacements. And x-axis we have the time. Yeah, depending on the frequency range, the seismometers are divided into these many categories: long period, short period, broadband. Long period, when we use the long period means if the earthquake has happened in 1,000 kilometers away, 2,000 kilometers away, then you have to use the long period. Short period means if the earthquake is local, means within 150 kilometers or 100 kilometers, then you can go for the short period. Then when we use the broadband, broadband is used for the both, if you want both teleseismic as well as local earthquakes. So these are not, these are the modern seismometers. These are fully compact. Olden days what happened, we need big space, but now you need just 2 feet by 2 feet. You can install the seismometer. This is one vendor RevTech. So it is having the three components inside. Okay. Yes, yes. Basically, we are recording the earthquakes. So means you have to record the clean signals. For that, what we will choose? First, we will go for the bedrock. Why bedrock? Bedrock is good for the signals. Suppose same without bedrock, if you install in the loose soil, what happens? Lot of attention will be taken. Whatever the original signal is there, it will get dissipated. For that reason, what we will do always, first option is, if the bedrock is available, we are happy. Simply on the bedrock, we will take the concrete and we will make it as a equal 2 by feet to 2 feet by 2 feet. Concrete will make the clean surface. Will take 2-3 days. After curing, simply you will install the seismometer. Now what happened? This seismometer will have the, suppose if the bedrock is not available, then what we will do? We will go for the digging. Up to when you will dig, we will go depending on where you will exactly get the hard surface. It may be 2 feet, 3 feet, or even in Pondicherry we went up to 10 feet also. Why? Pondicherry it is near to sea. That's why we went up to 10 feet after we got the hard surface. Once you get the hard surface, on that hard surface, once again you make the pillar, this pipe, that is called the pipe. On that pipe you install the seismometer. So this is our recording. This is for vertical and this is for the horizontal. These are the recorders. So what seismometer will generally give? Seismometer will give only analog signal. So analog signal will not understood by our computers. For that we need A to D converter, analog to digital converter. These are all recorders. So for that seismometer will convert the recorder, so that analog signal will convert into digital format and it will be seen in your computers. So this is how generally one seismic station will be installed. First you have to give the sensor that will convert into converter, and GPS. Why will use the GPS? We want to know the correct location where exactly we install the seismometer. So for a seismic station, these are instruments. Okay, seismometer, recorder, and GNSS means GPS. This is how your seismic station. Generally, we will install seismic stations in very remote places. The reason is because these seismometers are very sensitive. Even your footsteps also it will record. So if that much noise, what happened? Your analysis is you are picking up P and S waves are wrong. That's why always we choose the remote places where there is no cultural noise and there is no high tension lines. High tension also disturb your instrument. There is no railway tracks. There is no highways. So that whatever the signal you get, it is a pure signal. So this is called a pipe. Okay, this is the concrete pipe where you will install the seismometer, and this is the solar for continuous power supply. These instruments require hardly 12 volts. Okay, so if the power gone, your data everything gone. To get the redundant power supply, we use batteries as well as the solar plates, and this is the GPS. So get the exact location. Protection generally we go for the caretaker, sir, or we'll install the government institutes, government schools. Sometimes if the school is generally schools will be remote places, sir. If the remote place is not available, then we'll go for the some caretaker. We'll pay some money so that our each instrument entire setup will take 20 lakhs, sir, 20 to 25 lakhs. Maintenance every 3 months will go, sir. Every 3 months we'll go there.
This one, battery, I have to change this.
Okay. Every 3 months we have to go and collect the data sets. Yeah, these are the broadband, means up to 5,000 kilometers, 6,000 kilometers. Yes, but magnitude will depend. So at least 5 and above should be there. If the 5 magnitude happened in the Italy, it will record. Even US, it will record. So it will record both local as well as the teleseismic. That is why it is called broadband seismometers. Finally, we are coming to the end. So how to locate the earthquake? For locating the earthquake, what you have to do first? You first check your seismogram in your computer. Check the seismogram. Seismogram we have the time. So after getting the seismogram, first what you have to do? First you have to pick up the P arrival time. How you will get the P arrival time? Because it is a simple graph. On x-axis we have time, and y-axis we have amplitudes. So here we will get the P time. Similarly, S time. Now what you have to do? Suppose the P time is 4 seconds. S time is 8 seconds. Now what is the difference? 8 minus S minus P is 4 seconds. Means you know the time. Also, the global velocity of the earth is given by 8 kilometers per second. Means you know the velocity also. Global average velocity is 8 kilometers. But it will changes to place, but globally we take it as the 8 kilometers per second. Now you know the velocity, you know the time. From this what you can get? If you know the velocity and time, distance. What is the distance? Epicentral distance. Means from your station, at what distance this earthquake is happening. So this is your P arrival, this is your S arrival. So compute so oddly here what happened? It is 40 seconds. 40 seconds means 40 into 8, 320 kilometers. So that earthquake is happened at the 320 kilometers away from your recording station. So finally, what are the earthquake parameters means? Every earthquake you have these parameters. First one is the origin time. Origin time is at what time this earthquake is happened. Then location. Location means latitude and longitude. That is called the epicenter. And depth, and finally magnitude. So these are the importance parameters for a earthquake. So once you know the S minus P, we have the travel time curves. By using travel time curves also, you will find the approximate distances. So now what happened, for every station, you calculate the epicenter distance. For accurate location, we need at least 3 seismic stations. If you have 3 seismic stations, you will have to get the accurate location. So for 3 stations, from 3 stations, you know the epicenter distance. Take that epicenter distance as the radius and draw the circle. Then what happened? All the 3 circles will intersect at one point. That is your exact location. So you have already mapped now. Political map is there. You know the radius. Draw the circles. All the circles will intersect. That will give the exact. This is the manual way, but computationally we have the inverse theorems. Some inverse theorems there. Finally, magnitude. So how to calculate the magnitude? So this is the Richter scale equation by which you can calculate the magnitude. How to calculate the magnitude? It is the log 10 A, where A is the maximum amplitude. How will you get the maximum amplitude? From the seismogram. So from the seismogram, this is the maximum amplitude. If you know the maximum amplitude, 3 into log 10, 8. 8 means average velocity. And delta T is the difference, S minus P. That anyway you know the S time you know, P time you know. Now simply use this constant. Then what happens? Substitute all the values. Substitute the A value, substitute the delta T value. Finally, we'll get the magnitude. So this is Richter scale, and you can see, have a quick look. So from generally what happened, below 4 will not feel much vibrations. If you want to feel at least 4 and above. So from 4 and above, you will start feeling the earthquakes. And depending on your magnitude increases, your damage also increases. See, if the greater than 8, this is called the great earthquake. It happens very rarely. But below, very minor earthquake every day happens in terms of thousands, 10,000s like that. Depending on the magnitude, we'll define all these descriptive. So now data science is seismology. Okay, now what we'll do, we'll go for the demo so that all of you have the, because AML already people, they introduced na? Already. Orange also they have shown. Na? Okay, then now what we'll do, I will show where exactly this earthquake information comes. To apply the AML, first we need the data set. So how to get the data set? For that, if you go to Google Chrome and Google, there UGS earthquake. What happened? Okay. Oh, net is there. Net in. Yeah. If you click on that, all of you seen in Google Chrome, if you type UoH earthquake search, okay, then in first tab, search earthquake catalog. Yeah. So USGS, United States Geological Survey, every day they will give the earthquake information. Wherever the earthquake happens worldwide, it will give all the earthquakes information through this site, USGS site. Now what we will do, you can mention magnitude. What happened? You can get 2.5 and above, but our purpose will take from 4.5. Okay. Just click on 4.5, 4.5 plus. Or else you can give your custom magnitude also. Suppose if you want from 6 and above, there also you can give. Date and time, past 7 days, 30 days. We need at least, if you want to apply the AML, if you have bigger data set, good. So if we do, but present we don't have time, we will take 1 year data set. Okay. So for that you can go for custom, and you can take from 2026 start time as 25. Okay, exactly 1 year data set. And geographic region we want worldwide earthquake list. So after this, in output options, we have CSV format. Just click on the CSV format. Just click on CSV format and simply click search button here. Come to down and click on search button. Now save this as query 2025 to 2026. All of you done? Oh, internet unda sir? Internet. ఇక్కడ చూడండి సార్ వన్స్ ఫస్ట్ ఇక్కడ మ్యాగ్నెట్ సెలెక్ట్ చేశారు సార్ స్టార్టింగ్ ఓకే ఓకే just check once. అయిపోయింది uh, 4.5 and above. Okay, sir. So now we'll see, once it is downloaded, now we'll see what are the parameters inside that CSV file. For that, what we required? We required orange. All of you open the orange. ఏంటి మేడం సెర్చ్ అంటే సరిపోతుంది In output options, you have to select CSV. Then check once here. Once again, I'm showing. Here, magnitude you select 4.5. Date and time you have to select custom. And you have to select this is the 2025. And this thing you need not to change. In output options, go to output options. Click on CSV format. Comma separated value formatted. And come down. Come extremely down. There is option called CS search. Simply click on search. It will save the file. Time is not required. In custom, time is 1 year. 1 year means 2025 to 26. Just to the start time, only 25 gens. See, sir, like here in date and time, go to custom field. Here in the 2026, you make it as 2025. So that exactly 1 year data set will get. There is an option for search. Most of the people are not. Okay. Please, those who are not downloaded, please check to other systems. Now we'll go for fully. Then once you open the orange, just click on the file button, file widget. Okay. In file widget, just click on and you can open the recently open your file. The 2025 file is there now. Query underscore 2025-26. Just open that file. And click apply. Just click on the apply button. So following. What you have to do is go to your latitude longitude, madam. Just you click on this latitude once. No target, only latitude, longitude. Just click on 2 times. It will apply button will be highlighted. This is this is issue with the CSV file, or else directly you can import the CSV format file. There is another option, it's called CSV file import, but most of you repository already you download in the madam. You download, just you are uploading here, uploading to your workspace. Yes. I am also facing this problem. Now okay. Now if you want to see the contents in the file, what you have to do? Go to data table. Just connect the file to data table. Okay. Just click on the data table. Now this is the important. So now you will get all the parameters inside your CSV file. What is the first column? Time is what? Your origin time. In your format, maybe this some sorting issue will be there. Data table or what? Any sorting is done, madam? No. Same ఉంటుంది. Now time is what here? Time is nothing but your origin time. Origin time is the time at which earthquake is happened. Time that is called focus time. Next, ID means every earthquake. This is generated by USCS. Every earthquake will have unique ID. That ID is this one. Next, updated. What happened? It is automatically detected. Then later what happened? Some people will sit and review that earthquake, whether it really it is earthquake or blasting. That is called updated time. Place means what? That is called epicenter. Epicenter name. What is latitude, longitude? Your epicenter. Epicenter, latitude, longitude. Depth, at what depth it is happened. Magnitude, good. Mag type. Yeah. Here what happened in seismology, when you calculate the magnitude, there are different types of magnitudes depending on the source which you use. Suppose if you are using surface waves, that is MS. MS means surface wave magnitude. If you are using body waves, that is called MB. MB means body wave magnitude. MW, this is called the movement magnitude. ML means local magnitude. But worldwide, if you want to give your magnitude, then you have to use MW. MW is the worldwide known format. So like that, you have the magnitude type. Next, anybody 10? What is the next column? NST means number of stations. So for first equation, for first line, they used 107 stations to locate that earthquake. But what are the minimum stations we required? 3. If you use 107 means the location is much more precise. Gap means azimuthal gap. Azimuthal gap means generally when the earthquake happens from your station, you should be around 200 kilometers. If within the 200 kilometers, your location will be very well valid. That is called the azimuthal gap. D mean means a distance. Okay, minimum distance. RMS, root mean square, means when you calculate the location, what is the root means? It should be always 0.05. Below that, it is very good. Net means network code. So worldwide there are so many networks. US will operate some networks. Alaska will operate networks. Like that, every network will have some network code. Okay. AK means Alaska code. Like there are like that so many. US means United States. There are so many 10 to 15 networks are there. Type, yeah, this is important. Type means whether it is earthquake or blast. Sometimes what happened, blast also it will look like a earthquake. But what happened, their pattern is not same, earthquake and blasting. Horizontal error means your location error. Latitude how much error is came, longitude how much error is came. Always better it should be less than 5 kilometers. If less than 5 kilometers is there, then your latitude longitude is good. Yeah, depth error. So okay, whatever the error in your depth. Magnitude errors. Mag NST. How many stations are used for calculate the magnitude? Out of 107, it is not necessary to use all the 107. Wherever the good events are there, you can take those events. That is called the Mag NST. Minimum number of stations used for the calculating the magnitude. Status, whether it is reviewed or automatic. Okay, reviewed means it is perfect, final. Automatic means they have to review once again. Location source means which network they have provided. Magnitude source means from which network it is came. So this is how earthquake catalog look like. This is called the earthquake catalog. So what catalog contains? Catalog contains the origin type, main parameters. What are the main parameters for us? Origin time, latitude, longitude, epicenter name, depth. Remaining all are not that much important. These are all instrument related. So now second step is we have to plot the distributions. Distributions means frequencies. Okay. For that, there is option called distributions. See here. Just click on this widget, distributions widget. Just click on the distribution widgets. Now connect this data table to distributions. Just connect. Now open the distributions. Now we'll see one by one, okay, how the frequency will. Now simply bin width. Okay, what happened? Yeah. So here, not from the data table, you have to select from the file like this. From the file, you have to connect to the distributions and click on the distributions. Okay, sir. Click on the distributions. First, we will see the latitude. So if you change the bin width, see like this. So mostly at what latitude most of the earthquakes are occurring? At what latitude most of the earthquakes are occurring? At around at 60 degrees. In between 50 to 60 degree latitude, most of the earthquakes are occurring. Next, longitude. So longitude also, most of the earthquakes are occurring between the 150 to 200. Now, the important parameter. Now, what is your expectation? At what depth most of the earthquakes will occur? At what depth most of the earthquakes will occur? For that, just click on the depth. From this distribution, now tell me where most of the earthquakes, at what depth most of the earthquakes occurs? Yes. Mostly will get the within the 0 to 50. Very rarely it will go up to 80, 90, sometimes 100 kilometers also. But mainly you will get within the 50 kilometer depth. This is one of the important valid point. Now important is magnitude. So which magnitudes most occur? Here we are taking the 4.5. If it is less than 2, 2 will appear because bigger earthquake will appear very rare. Small earthquake will appear more. So that is how you can visualize. So small earthquakes occurs more, bigger earthquakes will take lot of time. So any doubts? Distribution, sir. It is Python, I can tell you, madam. This orange, I don't know an orange. Python, okay, I will explain. But there is no option here, I think. Suppose if you want to save this file, madam. Suppose if you want to save this distribution, there is a save button here. You can save in the any format, either PNG, JPG, any format you can save. Next, magnitude type. So which type of magnitude they calculate? This is purely dependent on UoH. So they will calculate the MB magnitude, means body wave magnitude more. NST. NST means number of stations. They use mostly up to minimum 100 to 200 stations. That's why their precision is more compared to. This is a gap, azimuthal gap. Azimuthal gap always less than 200. Mostly they are coming within 200. Okay. So like this, you can do any distributions. Distributions over. Okay. Now we'll go for a scatter plot. Scatter plot, so that you will get very good. Whatever I shown earlier, that you will get. Go to scatter plot. In scatter plot, what you will do? First, you give longitude, and y-axis you give latitude, and color. Color you will give the depth, and size you will give the magnitude. So now what you observe from this figure? Where most of the earthquakes are occurring? At the boundaries. So by using orange, you can find. This is the first slide I've shown while explaining. So this is how distribute. This is the real data set. This is the real data set. So like this, you can do anything. Suppose if you want to depth versus magnitude, if you want to do on x-axis you take depth, on y-axis you take magnitude. See. So most of the depths are occurring within the 200 kilometers. Most. So like that, you can plan. So finally, last task is this how to apply the k-means algorithm. So k-means is the one AML algorithm which will do the clustering. So depending on your magnitude and depth, it will cluster the entire data set, and it will give the final clusters. So now we'll see how to achieve that. Okay. For that, once you for that, first you have to extract the features. So what are the main features for clustering? Latitude, longitude, depth, magnitude. Okay. For that, there is a file called select columns. Select columns. So select columns is there. It is under transform. So in this, now you have to select the features. Only what are the features I have selected? Latitude, longitude, depth, magnitude. And these two are the metas. Metas means these are the categorical. One is the time, one is the place. So you have to put all these things to ignore values. You in the features, you have to select only 4. Latitude, longitude, depth, magnitude. Remaining all the things you have to move to your right side. There is a option in the madam here. I will show. Yes. So like that you have all the parameters. Okay. First, what we require, latitude I required. That's why I am keeping here. Longitude I required. Depth, magnitude I required. But magnitude type I didn't require. So just click on this. Then this left arrow will be activated. Just click on that. Then this will move to this. Similarly, NST, number of stations also I didn't require. So just click on this. Then left arrow will activate. Just click on this. So now only like that, keep only 4 features. These are called features, also called as the labels. Similarly, in meta also, you keep only time and place. Okay. So now we extracted the features. Latitude, longitude, depth and magnitude. Now in this, we have to apply the k-means. So k-means is the unsupervised learning. There are 2 learning, supervised and unsupervised. In unsupervised, what happened? Unknown variables, unknown inputs and unknown outputs. So here, go to unsupervised. Your panel, left panel, go to unsupervised and click on k-means. There is a widget called k-means. Okay. Yes. Now k-means activated. Now what you have to do? On selected columns, you have to connect the k-means. Means like this. Selected columns to k-means. Any warning you people getting? Same warning you people getting, na? So what is that earning we will see? Silhouette scores are not computed for samples greater than 5,000 samples. Means you are given more than 5,000 earthquakes. For that, what you have to do? First, you have to sample the data set. There is a widget called data sampler. Go to data sampler. Data sampler. See this on the transform, you have a widget called data sampler. Just click on that. Okay. Now connect selected columns to data sampler. So in data sampler, what you have to do? Just click on this. Now you can give. If I give 75%, I am getting 6,380. Means still we have to reduce. For 60%, 6380 means still you have to reduce. For 45%, oh sorry. Yeah, that also by using selector rows column. There is option called selector rows. Use that option also. Fixed sample size, but anyway we know now this one. This percent out of 100%, if you take 45%. Yeah, that is also done. If I take 70%, now my samples are 5,900. Still it is not accepted. It should be less than 5,000. So for 54%, yeah. If I take 54%, must another 2 minutes. That's all. Just 2 minutes. Okay, 54% and sample data. Now we have sampled the data. Now you apply the k-means. Go for unsupervised. Go for unsupervised and click on the k-means. Okay. Now connect your data sampler to k-means. Now I didn't get any errors because now samples are reduced to 5,000. So now now you open the k-means. Now you can give the how many clusters you want. Minimum we need 3. Okay, that depends on you. I am giving 3 to 5. You can give 3 to 6 also, your wish. Okay. Next, now how to see the clusters? For that, once again you have to go for the that plot or scatter plot also good. Go for scatter plot. Just use scatter plot. Just click, connect this and click on this. Yeah. Finally, this is your, in x-axis you select longitude, y-axis you select the latitude, and color should be cluster because we need the cluster now. At what cluster it will happen. And the size is magnitude. We are defining the cluster based on the magnitude and depth. Okay, if you click on any cluster, it will show which cluster it is. So this is C1 cluster, means magnitude is up to 5. C2 is 5 to 6. C3 is 6 to 7. Like that, it makes 3 clusters. So that is how you can see the clustering. Okay, due to time restriction, I am closing now. But if any doubts are there, all of you got this? Means if you have data set, how many clusters you got? 3 clusters. Because we taken 4.5 and above. Now what you will do? You take 2 and above. In go to UoGS and take the earthquake catalog as 2 and above, and try to find out the clusters, how many clusters you will get. Okay, thank you all. And hope. Thank you.
Thank you so much, sir. Your session was too good. It's wonderful. Thank you so much. Uh, much for coming here. I hope you will carry forward this knowledge to your students. Thank you so much. I just sent one link in your group. Uh, that was the evaluation purpose. That was for evaluation purpose. Fill it as soon as possible now only. Then we'll move for the snacks and then we'll get recession. Please do it now. Thank you so much.
Last one slide. Suppose after now we are seeing the global data set. If you want to do for the Indian data set, let's say after for NCS ethnic set, NCS, National Center for Seismology, they will also provide the